You take off from Earth and park your spacecraft somewhere near the Moon. You're now almost 240,000 miles away from your home planet. That's almost 100 widths of the United States. Now you take out a giant hammer and an enormous chisel using the robotic arms of your spaceship. You place the chisel at the Earth's North Pole and strike its head with the hammer. Earth splits open like an eggshell, and you see it, another planet. It's Theia, and it's hiding inside our planet like a yolk in an egg. You'd need to go back in time 4.5 billion years to find out how it got there. This beautiful nebula will soon become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Soon this jigsaw puzzle of debris becomes too heavy and dense. The temperature inside the giant is rising. Soon it gets so high that it triggers a nuclear chain reaction. Another second and bam! There's an explosion so powerful that the shock waves travel far into dark space. And the blinding flash from this blast can be seen from the other side of the Milky Way galaxy. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. You're interested in a small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core, while the oceans of lava are gradually cooling down. But a few tens of million years after the Sun's birth, you notice a strange object hurtling toward Earth. It's Theia. This small planet was born at about the same time as Earth, and now it's following a crazy spiral trajectory at enormous speed. Scientists believe Theia was kind of a ball Jupiter and Venus played with. Venus was pulling Theia in one direction. Then Big Brother Jupiter pulled it back. But the Sun makes up 99.8% of the mass of the entire solar system. That's why the star sets its own rules. It makes Theia move in almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Theia is the size of Mars and as wide as the Atlantic Ocean from New York to Portugal. A collision can't be avoided. Theia is traveling toward Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If the smaller planet crashes into Earth at a particular angle, Earth will most likely be torn apart, as well as Theia itself. The collision will cause a huge blast, visible on other planets even on a bright day. Nothing will be left but some burning dust and debris. Even if Theia touches Earth only lightly, it'll still knock out a chunk of our planet the size of Australia. But the collision with Theia happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shock wave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site. Soon it gets filled with boiling lava. The remnants of Theia and the ejected fragments of Earth begin to orbit our planet. According to one version, these fragments form two moons. At first, they travel together, but one day they get too close to each other and collide, forming one large space body. The other theory claims that all the shards start being pulled by the remnants of Theia. Sometime later, they form the moon as we now know it. At that point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Theia that we have different seasons and 24 hours in a day. Earth has lithospheric plates. These are enormous solid pieces that make up the crust of our planet. After the collision with Theia, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet. So, Earth gets some kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over nearly 4 billion years, simple single-celled organisms have been evolving into the life you see today. According to scientists, such a collision is a very rare event. The probability that somewhere out there, there's a planet like ours that has survived the same catastrophe is extremely small. This may be the reason why we are yet to find traces of other civilizations out there in space. Meanwhile, the remains of Theia are still here on Earth. Of course, it doesn't look like an entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see two huge lava blobs the size of entire continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Theia. They didn't mix with Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise those lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Theia might be on the moon. The Apollo space missions brought back many soil samples for analysis. Scientists have concluded that the moon is very similar to Earth in structure. People could drill deep down and take samples there. Then they'd analyze the blobs from Earth. If their structure matched, it'd be 100% proof that Theia did hit Earth 4.5 billion years ago. And that's how we got the moon. But for the time being, Theia remains somewhat mysterious. Scientists are still not sure that the planet actually existed. The whole idea perfectly fits the model of the moon's creation. But in fact, this incredible collision may have never happened.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
Now you travel 41 light years away from Earth to the planet 55 Cancri E. It's about twice the size of Earth and 8 times heavier. You take out your giant hammer again and use it to hit the chisel. The planet cracks, and you see, it's a giant diamond. The temperature on this planet is tens of times higher than that of Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon. Its structure changes. First, it turns into graphite. Some more pressure, and graphite turns into diamond. On Earth, diamonds form at depths below 60 miles, where the pressure is 50,000 times greater than on the surface. The temperatures there rise over 1,000 degrees, which is as hot as fire. Diamonds are ejected closer to the surface in volcanic eruptions. Still, people have to dig mines 1,500 feet deep to find these beautiful gems. The Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now imagine a diamond the size of an entire planet. You decide to fly back to the solar system. Your destination is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% the mass of Earth. Its surface is enclosed in an icy crust. It's about 19 miles thick. But what if you crack this crust with your giant hammer? Wow, Europa is completely covered in water. It's freezing here, 3 times colder than at the North Pole on Earth. The water turns into ice almost instantly, but the ocean beneath the surface is still liquid. Europa interacts with Jupiter gravitationally, just like the moon with Earth. This creates tidal forces and heats Europa's core. The core melts the ice around it. The result is a huge ocean, 2 to 3 times larger than all of Earth's oceans combined. Scientists believe that water is the basis of life. It may mean that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans. The water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria may live there. Europa is almost the same age as Earth. This means there's been enough time for living organisms to appear and evolve. Who knows? Maybe some advanced civilization is already blooming under this crust of ice. They may be building big cities and dreaming of conquering space right now. But the only thing people can do at the moment is send a probe to Europa and find out if life is possible there. The Earth has 3 main layers. 2 parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the moon, and made of nickel and solid iron. It's burning hot. The temperature at the center of our planet is the same as at the surface of the sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds. There are many miles of undiscovered areas beneath the crust we can't even come close to. Scientists found what appears to be underground mountains buried inside the mantle. Our planet is divided into 3 layers: the crust, the mantle, and the core. The crust is where 8 billion people, trillions of trees, and millions of animals live and thrive. There are also different types of crust in the land and the ocean. The oceanic crust contains unique rocks and is denser than the land crust. We all see how the Earth is divided and color-coded to show the crust, mantle, and core in textbooks. But there are also special layers in between that not everyone talks about. The mantle is divided into the upper and lower part, which is the transition zone. Since the mantle acts as the geological recycling center, the plate tectonics don't only move side to side, but up and down. It's actually why all the volcanoes appeared. The magma spews out to the surface or even underwater and then sinks back down and repeats. The transitions go down 250 miles and then 410 miles. And in this bottom layer, scientists keep discovering the hidden landscapes. The mountains in the mantle are more rugged and much larger than the ones on the crust. Scientists found a mountain range with peaks higher than Mount Everest. Some of them are as high as 600 miles. When the continents were still landlocked together, there may have been some hidden lands now underwater. Theories suggest that Iceland used to be part of a larger microcontinent, Icelandia, which connected present-day Iceland with Greenland and Scandinavia. The idea digs even deeper to a greater Icelandia, which includes Britain. But after the split, these bigger lands sunk with everything in it. There are also theories about New Zealand being part of Zealandia, a hidden microcontinent within the same region. So it could be that these mountains used to be part of old Earth that are underground over the billions of years of natural occurrences. But still, it isn't very likely. One theory is that these underground mountain ranges could be leftover slabs of rock that descended from the surface to the transition zone from the moving of the tectonic plates. As they sink, the large pieces break down into smaller ones, and as they compile over the millions of years, they form what appears to be underground mountains. Since the mantle is the geologic recycling zone, it's likely that the rocks down there used to be part of the surface. They weren't large pieces of land that got hidden, just like dogs hide bones in the garden, but it takes way more time to hide mountains. Some parts of the mantle appear to be smooth, while others aren't so much. The parts that have a cluster of rocks could contain hidden elements in the underground mountains. The smoother parts don't have much seismic or volcanic activity, while the rough parts do. The best way to study those underground landscapes is to wait for an earthquake or a volcano eruption to happen. Seismologists can observe the Earth's interior with special scanners, just like doctors use ultrasound to examine a patient. They can even see minor details and not huge chunks of rocks. A strong enough earthquake can send shock waves to the Earth's interior, even through the core and back up to the surface. Depending on where they occur, seismologists can observe and study the intensity of the waves as they move back and forth. On smooth rocks, the waves can travel in a straight line, but once they reach a rough area, the waves tend to scatter. The temperature and composition of the materials can make the waves move faster or slower. But this info isn't exactly accurate and won't contribute a lot to the actual data of the underground mountains. So by analyzing the scattered waves on ships and utilizing the Earth's magnetic field, scientists can figure out everything they need to know. But these studies are only good enough to figure out the interior in today's state, not how the Earth changed over the past 4.5 billion years. However, scientists are certain that mantle material still dates back to the beginning of Earth's original formation. The question, why not just dig a hole to the center of the Earth and see what's going on down there, might seem logical. The deepest hole humans have dug so far is the Kola Deep borehole in the Russian Arctic that goes more than 40,000 feet deep. The locals claim they can actually hear screaming coming from below. It took almost 20 years to drill as far as they went, but it's literally merely scratching the surface of what's underneath. They dug about 1/3 of the crust, which is only 0.2% to the center of the Earth. Getting there is beyond us, just like trying to reach the sun. No human can handle the amount of pressure down there. Going down the Mariana Trench, the Earth's deepest point, requires special gear to withstand all the immense pressure. It'll cost a fortune to build that tech to get us to the center of our planet. Evidence of diamonds buried deep in Brazil shows that everything we do on the crust's surface can affect things miles below, even towards the mantle. Scientists dug up 6 diamonds that could hold tiny mineral grains. As they're called in the mineral world, these inclusions have a chemistry composition where they originated deep in the Earth. Typical diamonds are formed at depths less than 125 miles in the upper mantle, where it's extremely hot. The high pressure and boiling temperature down crystallizes carbon and creates diamonds. But humans can't dig all the way down there. They mine them by detecting where a deep volcanic eruption happened that expelled these diamonds to the surface. These eruptions occurred millions of years ago, when dinosaurs used to rule the Earth. They shot out the diamonds that were in the mantle and are now embedded within the cooled down volcanic material. That's where people mine them. But these special diamonds found in Brazil originated from a much deeper point than usual, which can further help scientists study the depths of the Earth. They can extract these inclusions and analyze them in a lab to tell where exactly these minerals come from. In the lab, scientists study inclusions, each just 15 to 40 microns wide, less than a quarter width of a human hair. They found out that they contained many types of minerals found in volcanic rock on the surface. The carbon composition of the magma from the surface is much different than the ones deep in the Earth. What's crazy is that these diamonds with special inclusions can only be found 435 miles in the lower mantle. With only a few samples of them found, we don't know what else lies beneath us. It's possible that those mountain ranges underground, taller than Mount Everest, can have traces of diamonds all around, which would prompt excavators to dig them up and saturate the market with them. These diamonds are less flawed than the usual ones and might even come in many sizes. It's possible to see diamonds as large as a car or as small as a grain of rice. There might even be new diamonds with different chemical compositions than the ones we find near the surface. The largest diamond in the world is the Cullinan, which can fit in the palm of your hand. It weighs around 1.3 pounds and is 3,100 carats. It was found in 1905 in South Africa. For anything to exist on Earth, you need carbon. In a nutshell, the carbon cycle is when plants and algae release carbon dioxide into the atmosphere or dissolved in water through photosynthesis. It's converted into carbohydrates and stored as fat. Later on, carbon dioxide is released into the atmosphere through breathing, which the plants benefit from, and the cycle goes on. Scientists claim that there might even be a carbon cycle in Earth's interior. The oceanic crust has a lot of carbon sediment that could mix with the upper and lower mantle layer. But there still isn't enough evidence to support this. The deep diamonds might be the key to popping open that theory. Only time will tell.
Not so long ago, astronomers discovered a planet that got the name of UCF 1.01. This world is about 33 light-years away from Earth. This makes the planet our next-door neighbor, in the cosmic scheme of things, of course. Honestly speaking, the space body is only a planet candidate because astronomers haven't measured its mass yet, but they have high hopes. The wannabe planet is very different from our Earth. Just 1.7 million miles away from its star, it completes its orbit in a day and a half. It's a scorching, deserted world with the temperatures at the surface rising up to 1,000 degrees. Even more astounding, the entire planet is likely to be covered in magma. Even if UCF 10 ever had an atmosphere, it has definitely boiled away by now. But then, the question is, what if Earth once went through some catastrophic event and it left our planet in the same state, boiling hot with the surface covered by a thick layer of lava? Would people manage to adapt to such conditions and move to live underground? It sounds unbelievable, but experts are sure that with time, humans would turn into healthy and rather happy mole people. Of course, life would be very different than today. No more sunsets and sunrises. No more traveling by plane and space exploration, unless people found a way to launch a rocket from under the ground. No more picnics in the park or sunbathing at the seashore. People would have to build a vast network of underground tunnels that would connect major cities. The most likely transport in this new world would be silent high-speed trains and electric cars. After moving underground, people would have not only physical but also psychological difficulties. In the beginning, their new home would be a dark, barren place, without fresh air and devoid of any color. To adapt to these tough living conditions, people would have to make some design changes. Greenhouses, well-lit parks with trees and illusions of the sky, familiar scents and sounds. All this would help people to adjust to their new life. After living underground for several generations, people would start to look a bit different. pale because of the lack of sunlight, with sensitive large eyes adapted to dimmer lighting, and more developed lungs. As for the very possibility of living underground, well, hear me out. You might imagine the Earth's depths as a huge mass of compressed solid rock. But the reality is different. This mass is heavily cracked. Water runs down the fractures and cracks in the planet's outer layer, the crust. Some of these streams reach the depth of many miles. In other words, subsurface Earth could probably support plant and animal life. If people lived underground, they wouldn't have a shortage of fresh water. Its reservoirs in the planet's interior contain 100 times more water than all the lakes, rivers, and swamps combined. Plus, this water trickles through the soil that acts as a purifier. But people would have to be super careful to keep the sources of water intact. Otherwise, the underground cities would get flooded and turn into giant water-filled traps. It would also be a great challenge to live without sunlight. Plants can't survive without the sun's ultraviolet light. It's absolutely necessary for photosynthesis because sunlight is used to get nutrients from carbon dioxide in water. One of the byproducts of this process is oxygen, the thing people can't live without. So, no sunlight equals no plants equals no oxygen. Sunlight is also crucial for humans. For example, it helps your brain release serotonin, a hormone that boosts your mood and makes you feel focused and calm. Thanks to the ultraviolet B radiation in the sun's rays, your skin produces vitamin D. It's vital for a strong immune system and healthy bones, teeth, and muscles. That's why people would have to find a replacement for sunlight. Luckily, LED lamps that can give off UV wavelength could produce the light human bodies and plants crave so much. In the new underground world, there wouldn't be large sunlit fields. Instead, there would be sprawling greenhouses with LED lights shining from the ceiling. Special machines would feed plants and crops with recycled water rich in nutrients. In some areas, located in the narrow underground faults, people would use something like shipping containers instead of greenhouses. These containers would be packed with vertical rows of plants and blue and red LED bulbs. As for people, they would have to follow a vitamin D-rich diet. It'd mean eating a lot of egg yolks, cheese, fish, spinach, soybeans, and so on. If these foods weren't enough, vitamin D supplements would do the trick. Without daylight, people would have problems with their circadian rhythms that regulate sleep patterns. If you were isolated somewhere without a glimmer of light, you would easily sleep for 48 hours at a stretch. That's why people living under the Earth's surface would rely on artificial lights to control their internal clock. There wouldn't be any problems with electricity. It would be produced with the help of the Earth's inner heat. Such kind of energy is called geothermal, from the Greek words geo, earth, and therm, heat. It can be extracted from hot water and rocks. Like an onion, our planet is made up of several layers. The innermost part is a solid core around 1,500 miles across. Made of iron, it's surrounded by a scorching outer core. It's up to 1,400 miles thick and is mostly composed of liquid nickel and iron. The next layer is the mantle. Even though lots of people picture it as lava, the mantle is actually rock. But this rock is so hot that it flows, just like road tar. The temperature in the Earth's core is as high as 10,800 degrees Fahrenheit. That's almost 1,000 degrees more than at the sun's surface. The mantle is also blistering, from 7,000 degrees at the boundary with the core to 400 degrees in its outer parts. No wonder people wouldn't have any difficulties with transforming all this heat into electrical energy. But because the insides of our planet are insanely hot, people wouldn't be able to build cities too deep underground. All inhabitable areas would most likely stay closer to the surface. The Earth's outermost part, the crust, is like the shell of a hard-boiled egg. It's broken into gigantic blocks called tectonic plates. When two plates collide, mountains get formed and new rifts appear in the seafloor. They have different width, from 25 miles thick beneath the continents to 5 miles thick beneath the oceans. These blocks travel around, floating on the Earth's mantle, slowly, almost imperceptibly. It means underground cities would also move, but it would be next to impossible to notice these movements. Oh, by the way, people started to believe there might be another world inside our planet in the 17th century. The idea got the name of the hollow Earth theory. It claimed that half the planet was taken up by its surface weight. Below the surface, there was some empty space. A small sun hung at the very center of that cavity, creating a comfortable tropical environment on the inner side of Earth's surface. One could enter the Earth's interior through one of the openings near the South and North Poles. A race of advanced humans was believed to live inside the planet. They were peaceful and lived for centuries. Well, obviously not humans. They had unique technologies, for example, flying vehicles. And since the climate inside the planet was better than that on the surface, this race was much stronger and healthier. Even though this idea sounds like science fiction, several famous scientists supported it. Some people are still sure there's another world inside our planet. But if the Earth was hollow, it wouldn't have a magnetic field. And without a magnetic field, solar winds would rid our planet of its atmosphere in the blink of an eye. This would leave our green planet deserted and uninhabitable, like Mars is. The magnetic field on our planet exists thanks to the processes going on in its very much not hollow center. Liquid metals are constantly moving in the Earth's outer core, generating electric currents. When the planet rotates around its axis, the electric currents form a powerful magnetic field. The sunward side of the magnetosphere is as large as 10 Earth's radii, and the other side stretches out in a magnetotail that spreads for 200 times the Earth's radius.
At 12 a.m., young molten Earth collides with another planet called Theia. The moon is formed. From 12 to 4:30 a.m., the planet and atmosphere are morphing. The continents merge to form supercontinents. They break up again. This happens every 400 million years. That's every 2 hours on the clock. At 5:30 a.m., we see the first single-celled organisms starting their life in the ocean. It's 8 a.m. when the first viruses emerge. By 11 a.m., photosynthesizing bacteria have managed to take in enough sun to fill the atmosphere with oxygen. It takes 1 billion years. That's 6 hours on the clock. At 11:35, we have the first snowball Earth. Even the oceans turn to ice. Don't worry, everything will melt by noon. At 1 p.m., we have special cells with internal organs coming to life. 3 hours later, they'll start to divide into 3 groups that will eventually become fungi, like mushrooms. Let's fast forward while these cells go from simple to complex life forms. At 7:20 p.m., something familiar appears: sponges. It's 7:55, and the Earth freezes over again. It melts in 2 minutes. 8 p.m., and look in the ocean. We have the first comb jellies appearing. At around 8:30, the Earth's ozone layer appears. In just 2 minutes, the ocean is filling with plants. By 8:45, life is flourishing in the sea. We now have jellyfish swimming around corals. Starfish are on their way. At 8:52, we can see trails on the ocean floor. Creatures have begun to crawl. It's 9:10 p.m. The sea creatures decide to explore the land. 30 seconds later, different animals and plants emerge. They spread all over the planet in an instant. 9:41. It's time for the first insects. They feed on newly formed plants and trees on land. By 9:45, we have the first 4-legged animals appearing in shallow waters. At 10:10 p.m., those 4-legged creatures are splitting into groups that will later become mammals, reptiles, birds, and dinosaurs. By 10:30, everything vanishes. Mass extinction takes place. Either a huge asteroid or an enormous volcanic eruption causes it. Only 5% of the species survive. 10:34, and the dinosaurs are finally making an appearance. The first one was the Nyasasaurus, but experts aren't sure if it was the real deal or a relative turning into a dino. 1045 marks another mass extinction. The early dinosaurs survive it and take the opportunity to spread all around the world. In 5 minutes, the Tyrannosaurus will appear. By 11 p.m., we have the first birds appearing in Europe. It's 11:15, and mammals are splitting into their groups. They'll branch out, forming whales, elephants, armadillos, and primates. By 11:17, dinosaurs are reaching their full size. The biggest one ever is the Argentinosaurus. It's the length of 10 school buses and tall enough to peek into a 7th floor window. It's 11:26 when a giant asteroid smashes into the Earth. Dust flies everywhere. A few seconds later, everything clears up, but the dinosaurs have already disappeared. With the dinosaurs gone, the few mammals left can take over the planet. At 11:30, the primates separate into 2 groups, and one of those will become apes, gorillas, and, sometime later, humans. It's 11:58 p.m. The chimpanzees and bonobos appear. 15 seconds later, the hominin species begins to walk on 2 legs. It's 11:59 and 23 seconds, the time when humans appear in Africa. A second later, they've migrated all over the world. They don't have a language, and they can't use or create tools. That happens at 11:59 and 58 seconds. 2 seconds before the day ends, 100,000 years ago, our complex human species appears.
There are thousands of satellites flying around Earth. Some are needed to provide communication and GPS. Others monitor the weather and climate changes. In 2009, one of these satellites was circling our planet and scanning the waves reflected from the Earth's surface. The satellite was looking for changes in the emission of carbon dioxide coming from the planet, but it found something else. Something that completely changed the principle of studying the Earth's ecosystem. The source of the wave was utterly unknown. Scientists wanted to know the nature of these waves, so they tuned the satellite's instruments to the desired frequency and looked at the Earth. At that moment, they saw an unknown red glow surrounding our entire planet. In some places, the glow was weak, and while in others, it shone brightly. At first, everyone assumed that it was sunlight reflected from the Earth and produced unknown red particles. However, the analysis showed the glow's source was on our planet, and it never came from the sun's atmosphere. The glow may be the result of humanity, city lights, exhaust fumes, or something else. But again, scientists made a mistake. The brightest red light was radiated from places without humans. There were no traces of modern civilization. It turned out those places were swarming with plants. The brightest waves come from the Amazon jungle, croplands of the Midwestern U.S., northern evergreen forests, and other green areas. To understand the cause of the planetary red shining, scientists began to restudy plants. Every living tree, leaf, or blade of grass absorbs carbon dioxide and produces oxygen necessary for life. Plants manage to do it thanks to their ability to absorb sunlight. This process is called photosynthesis. New research showed that every plant emits a red glow during photosynthesis. It happens because they don't absorb all the incoming sunlight. They give part of it back in the form of a red glow, and this part is only 1% from all the receiving sunlight. This small amount of red light is impossible to see with the naked eye, but if you look at millions of plants from afar, the wave can be noticed. But still, with the help of special devices, this new photosynthesis process is called chlorophyll fluorescence. This is a hugely important discovery that allows people to monitor the state of nature. Previously, changing the color of trees helped us understand that something was wrong with the forests. For example, if a tree turns yellow, then it's probably not healthy, and we could observe the plant's state through satellites. But there are many exceptions to this method. In autumn, in many regions, almost all trees turn yellow and shed their leaves. But in any case, this monitoring system is not very effective. If we see an unhealthy tree because of its yellow leaves, then it's already too late to cure it. Any change in the red glow allows determining problems with the vegetation before the leaf color changes. And this helps to do something just in time. With the help of satellites, people can now see the problem areas of the planet. Also, the glow helps understand how much carbon dioxide and oxygen trees emit. We can learn about the plant's problem even before it occurs. The glow also comes from seaweed in phytoplankton. More than 50% of the oxygen in the atmosphere comes from oceans. Theoretically, it's possible to scan other planets in search of the red glow, to understand which of them has a habitable atmosphere. The red glow doesn't only come from our planet. In the depths of outer space, through a telescope, you can see the Horsehead Nebula, one of the most beautiful places in the universe. It's located in the constellation Orion. People called it so because of the similarity with the thrown-back head of a horse. This nebula was first discovered in 1888. This huge area of space is illuminated with a rich red color. This beautiful shining is possible because there are many super powerful blue stars inside the nebula. Their energy is absorbed by one of the most common substances in the universe, hydrogen. Hydrogen atoms receive such a strong charge from super powerful stars that they emit red light when they collide with electrons. Just imagine if a super powerful star was burning near our solar system, or if our planet was located in the Horsehead Nebula. Perhaps we wouldn't notice the red glow, so we would live inside this glow. We can observe beautiful multicolored nebulae only from the side, being thousands of light years away from it. Let's go back to our planet. By the way, there's another amazing glow surrounding Earth. It seems to be pulsating, shimmering with different colors, constantly changing its shape. If you look at our planet through special equipment, you will see that it's located inside this pulsating, uneven bubble. The bubble layer is quite thick. It covers the planet at an altitude of 50 to 400 miles above the surface. Even the International Space Station flies inside this glow. Almost all the satellites surrounding the Earth are in the zone too. It's called the ionosphere. It ensures the operation of communication in navigation systems. It helps radio signals and GPS to get to our mobile phones. The ionosphere is a layer of charged particles that separates the upper layers of the atmosphere from pure space. In simple words, this is a sort of an edge of our planet, the boundary between the place where we can breathe and the complete vacuum. Sunlight takes 1 or 2 electrons from the gases around the Earth, so these gases become charged particles. A huge accumulation of these floating particles creates the ionosphere. It's constantly changing its shape and size, as the planet is rotating around its axis and sunlight's falling unevenly. During the day, the ionosphere is always larger than during the night. Because of this, it looks pulsating and moving in different directions. This instability shortens the life of orbiting satellites and often puts them out of action. But it also helps to provide communication. Radio signals and GPS pass through it and reflect from charged particles and fly to our phones and navigation devices. Earth is not only glowing but also pulsating. An unknown pulse is coming from the surface or the depths of the planet. The pulsation repeats every 26 seconds and never stops. At some point, it's similar to a human heart. It's working almost in the center of the chest. Earth's pulse comes from the planet's center, the equator, but the exact location of the source is unknown. In the 1960s, the pulse called microseism was discovered by seismologists in the US. More than 50 years have passed, and scientists around the world still don't know the nature of this phenomenon. It seems as if our planet has a heart hidden inside the crust. According to research, this heart may be located in the southern or equatorial part of the Atlantic Ocean in the Gulf of Guinea called the Bight of Bonny. Every winter, the pulse increases, but then its strength weakens again. Scientists began to explore this place and put forward the theory that the ocean creates the pulse. Waves cross the surface and hit the continental shelf of the planet. This impact deforms the ocean floor. A strike to any flat surface works on the same principle. Hit any plate with a hammer, and you will feel a vibration through the object. The same beats are created by waves hitting the coastline. There are waves all over the world, not only at the equator. So why does microseism occur at the equator? Because in this place, the sun heats our planet the most. Solar energies increases storms and winds, accelerates ocean currents. Also, in 1980, geologists found out that microseism pulsates powerfully during storms when the waves hit the shore stronger. Not all scientists agree with this theory. Some researchers believe the planet is pulsating because of the seismic volcanic activity, and there's one that's located on one of the islands in the Bight of Bonny. The place of pulse origin is close to this volcano, but further observations have shown that microseism can be found in all places of the Gulf of Guinea. Scientists still can't prove any of the hypotheses.
Millions of people around the world go out on the streets and rooftops to look at the amazing cosmic phenomenon. Another planet right next to the moon, a big red one. At first, everyone's excited. Mars showing up out of nowhere is having a strange effect on humanity. Just as the moon can affect the psychological and physical state of some people, Mars's unexpected visit is causing people to behave pretty strangely. Every night, the sky is lit up by the white light of the moon and the red glow of Mars. Many people get a sort of instant insomnia. Some even stop drinking coffee because they no longer feel sleepy. Mars brings out energy and a little wildness in people, making them laugh more, and even drives a few poor people crazy. They begin to go out of their houses more often and enjoy the unusual night sky. A few days later, everybody can see what's happening. Mars is getting bigger. Scientists announced that the red planet is slowly moving towards Earth. A collision is inevitable. Earthlings only have a few years left. A few months ago, a huge asteroid crashed into the red planet with such force that Mars simply flew out of its own orbit and went rogue. The chance that Mars would fly close to Earth was always going to be pretty high. After about 3 seconds of being announced, the news went viral, and panic set in. The situation's getting worse and worse. The closer Mars gets, the more it affects people on a physical level. Hundreds of videos pop up showing collision simulations of Mars and Earth. And there's no happy ending. Want to see what happens? One famous blogger asks her followers. The Earth's almost completely covered with water, and Mars is all dust, sand, and rocks. Then she puts a huge watermelon in the middle of her room. From the far end, she launches a bowling ball at it. Strike! Mars looks almost the same size as the Moon now. It's about to come into the Moon's orbit, and it's affecting the Earth's magnetic field. Floods, hurricanes, tsunamis, powerful thunderstorms. They go from bad to worse. Animals go crazy. Birds no longer migrate south. The polar northern lights appear in the Caribbean. The economy isn't handling the news that well. People stop showing up to work. Why wouldn't they? They just want to have fun and be with loved ones. There are enough resources on the planet to last until the catastrophe, so no one's even trying to fix the Earth's problems. Clothing, food, cars, yachts, whatever, everything loses its value and becomes free. Every day, huge street parties pop up all over the world. People decide to live their last months in peace and harmony. The global catastrophe is uniting humanity like never before. To go out with a bang, Earthlings team up to organize a huge rock concert. The red giant destroying our beautiful blue planet. Yeah, rock and roll's the perfect soundtrack. There's just enough time to eat, dance, party, and listen to good music. Huge stages are built all over the planet. It's every musician's last concert. During all that preparation, hope suddenly appears. Scientists have calculated all the events that'll occur when Mars crashes into Earth, and they have a simple plan. Luckily, humans had already planned on moving to Mars, so they already have been building spaceships for years. There's no time to get to another planet before the collision, but the good news is that people can wait out the disaster just outside Earth's orbit. You get to sit in a space station, munch some popcorn, relax, and enjoy the show. When the dust settles, it might just be possible to return to Earth, or what's left of it. After learning about this plan, people start working on finishing the ships night and day. Everyone in the world pitches in. There are still 2 years left before the big day. The huge concert stages are converted into more space stations. Mars is now giving people more energy, and with epic teamwork, people manage to create thousands of stations in just a few months. That's what happens when 7 billion people work together. Farmers, physical therapists, chefs, engineers, athletes, accountants, all on the same team. Mars is now closer to us than the Moon. The red giant blocks out the sun, and our planet is plunged into darkness. There are only a few days left. People are working like ants in a massive colony, putting the finishing touches on several 100,000 space stations. It takes 4 whole days for everyone to get on board. Plus, there's the loading of supplies, animals, fish, seeds, plants, vegetables, fruits, video games, fruit roll-ups. The red giant is scheduled to enter Earth's orbit in a couple of days. That's when it will really pick up speed. Mars is only a little more than half the size of Earth, but up in the sky, it looks infinitely huge. The ships start taking off. People take a last look around, memorizing every inch. In a few hours, it'll all change forever. The stations fly up far enough away to clear any orbits. Two worlds colliding together should still have a soundtrack, though. Rock stars on every ship organize an outer space music festival. To the awesome sound of rock, Mars enters Earth's atmosphere and burns a thin layer of its own surface. This releases an incredible amount of energy. It gets faster and faster and smashes into the Pacific Ocean. A huge blast wave sweeps across the entire planet. Everything is lit up by flames, and everyone on the ships has to put on sunglasses to avoid being blinded. Our blue planet is turning into a fiery one. The dust of Mars mixes with the water of Earth. The force of the impact goes through the Earth's crust into the liquid hot magma. Hundreds of pieces of Mars, some the size of entire countries, are somehow floating in the atmosphere. The collision generates so much energy that all oceans boil and evaporate. Seas and rivers of molten metal are now spreading all over Earth. Days, weeks, months pass. A belt made up of bits of Mars forms around the Earth. It's like a fiery version of Saturn. It'll take a long time before it's safe to land back down. But humanity can't stay alive on the ships all that time. Food, water, and oxygen will run out after a few years. But scientists already have a plan. The ships flip a switch and become huge cryochambers. The ships are equipped with energy panels, and the roasting hot Earth's giving off a lot of energy. Totally enough to keep the ships working while everyone on board takes a few thousand-year nap. As soon as the planet cools down, humans will wake up. Hundreds of thousands of years pass. One day, alarms go off simultaneously on all the ships. People wake up, slowly. Their bodies are exhausted, but after a few billion cups of coffee, everyone's ready to go. Down on Earth, new continents should have formed, and the atmosphere is most likely way different. The planet might have lost its original orbit, so it might be spinning at a different angle. The seasons as we know them, gone. All the water on Earth evaporated in the first few hours. But there were huge glaciers on Mars, which might have melted on impact. Mars may have shared its water with our planet. The clouds of dust and dirt should have settled by now, and the ground should be pretty good for growing stuff on. All that magma probably spewed up a bunch of useful minerals and chemicals. It's going to be difficult, but humanity somehow must adapt to the new Earth. People are ready for anything. All the Earthlings run to the nearest windows to see what their beloved planet looks like after all these centuries. Where is it? People are craning their necks, looking out at the empty spot where the Earth used to be. The impact of Mars was so strong that it pushed the Earth out of its orbit around the Sun. It's gone. Great. What are we gonna do now? Some bearded guy grabs a guitar and says, "Let's play!"
We have found out quite a lot of things about the past of our planet, but can we figure out its future? And I mean, not guess or predict, but estimate scientifically. Before we move on to assessing the future of our planet, I suggest we define the future of our channel. Please support our work by subscribing and liking. Thank you. Well, experts think we might learn more about the future of Earth with the help of a few long-term factors. Among them, we've got the rate at which the interior of our planet is cooling, the chemistry at Earth's surface, and even the way our planet gravitationally interacts with other objects in the solar system. And don't forget that we humans also cause serious changes to our home planet. For example, take climate engineering and other technologies. Some people even believe that technology might be what will lead humanity to extinction. If it ever happens, the planet will begin to evolve naturally and much more slowly. Experts think that over periods of hundreds of millions of years, certain space invaders can lead to mass extinctions on Earth. I mean, comets and asteroids that might crash into our beautiful blue world at one point in the future. Another threat from space can be a powerful near-Earth supernova. It is a gigantic explosion, the largest in space, and it unleashes enormous amounts of energy. The temperature at the core of a supernova is often 6,000 times higher than that in the Sun's core. It can reach several billion degrees F within microseconds. After that, atoms get crammed together so infinitely close that the squeezed core recoils and the star explodes, creating a superheated shock wave. If a supernova ever occurred around 30 light-years away from Earth, we'd have huge problems. An incredibly powerful blast of radiation would bring a massive influx of high-energy neutrinos. Our planet would be vaporized in just a fraction of a second. Even the shock wave would have enough force to wipe out our oceans and the entire atmosphere of our planet. Another prediction says that while the Sun is orbiting the Milky Way, stray stars may approach our solar system. They can get close enough to have a disastrous influence on our planet. Such an encounter can also lead to comets in the Oort clouds becoming more active. The Oort cloud is a region of space filled with icy celestial bodies, orbiting within half a light-year away from the Sun. And if something, for example, a wandering star destabilizes this region, the number of comets reaching the inner solar system and US will likely increase 40-fold. But while scientists can't be sure about asteroid impacts or supernova explosions, they can forecast large-scale geological events. One theory claims that Earth will continue to experience glacial periods for quite some time. Also, the movement of tectonic plates will probably result in the appearance of a new supercontinent. It might happen in 250, 300 million years from now. The changes in the luminosity of the Sun, which will become brighter and brighter, will lead to an increased level of solar radiation reaching Earth. It will eventually cause a drop in the level of carbon dioxide in the atmosphere around 600 million years from now. If this tendency continues, plant life will disappear from the face of the Earth. Of course, it will also influence animal life, since plants are the base of the animal food chain on our planet. In 10 billion years or so, the luminosity of the Sun will become 10% higher than it is now. It will turn the atmosphere of the planet into a moist greenhouse. The oceans will start to evaporate. In around 2-3 billion years, the planet's magnetic field might stop functioning. 4 billion years from now, a rise in Earth's surface temperature will lead to conditions resembling present-day Venus. By that point, there won't be any life left on the planet. And finally, the Sun will most probably absorb Earth in around 7.5 billion years. It will happen after our star enters its red giant phase and expands way beyond the current orbit of our planet.
This is Earth, 335 million years ago. I wasn't around then, but there's just one supercontinent, Pangaea. See? Let's watch it shift around and fast forward. Okay, here we go. It just split into two huge pieces. Australia goes this way, North and South America go that way. Africa, Asia, Europe, forming, and there we go. The planet as it is today. Let's keep going. I mean, the continents are always on the move. Over time, some of them will crash into each other. Others will break apart. But that'll take about 100 million years. Better put it on super fast forward. 100 years from now, humans keep spitting carbon dioxide into the atmosphere, and the planet's already warmed up a bunch. The world's ocean levels have risen about 4 feet. The Bahamas? They've totally disappeared. 200 years from now, the Earth's population is about 19 billion people. The climate's gotten even warmer. We're packed in like sardines over here. New medical tech makes it possible to live to 180. But why? Fossil fuel reserves of oil and gas? Long gone. Oh, and the continents have drifted over 16 feet. The Voyager 1 space probe's about to enter an asteroid cloud at the edge of the solar system. It's the most distant man-made object in the universe, I guess. 1,000 years from now, thanks to better quality food, humans are now 7 feet tall on average. Technology solved the pollution and fuel shortage problem. Humanity's doing just fine. Robots do all the work, we just play around all day. Ocean levels have crept up another 10 feet. Islands like the Seychelles, Maldives, Galapagos, and many others have gone underwater. Denmark, the Netherlands, Eastern England, Thailand, and Vietnam are only partially underwater. There's been a huge human migration these last 100 years. Fast forward about 5,000 more years, and it's the year 8113. Humanity's getting ready to open the crypt of civilization. It's a hermetically sealed room in Georgia, in the States. Bad Georgia. It was created in 1940, and it's full of about 800 books on microfilm, recordings of famous people's voices. It's also filled with bits of technology from that time, like a toaster, a radio, and a typewriter. Some awesome people created the crypt of civilization in case humans experienced a major catastrophe in the distant future and had to rebuild civilization from scratch. We'd all go back to using typewriters. 15,000 years from now, our planet has changed its tilt, and the Sahara Desert is now a tropical paradise. Years of rain turn the dry desert into a wild jungle. 30,000 years from now, the Voyager 1 space probe has finally left the asteroid cloud at the edge of our solar system. If it doesn't collide with anything, it'll be flying in the dark, wide-open outer space for a very long time. 50,000 years from now, the climate's changing a lot. The temperature on Earth is beginning to drop, and we are approaching the beginning of a new ice age. The radio signal with a special "Hello, all you aliens out there" message sent into space in 1974 has reached its destination. The message contained the human number system and data about our DNA and our solar system. If there was someone on the other end to receive this signal, we might have a response from them. 100,000 years from now, one of the largest known stars in our galaxy, Canis Majoris, explodes with enormous force. The explosion of this supernova can be seen from Earth, even during the day, and the nights are much brighter because of the new strong glow in the night sky. What's new on Earth? Supervolcanoes start erupting all over. These volcanoes spew colossal amounts of lava and ash everywhere. Thick black clouds cover most of the sky. This prevents the sun's rays from reaching the ground, and the temperature on our planet drops even lower. Humans mostly live underground anyway, so it's no big deal. Because the stars are gradually moving in different directions, the usual constellations are starting to change shape. Soon, we'll need to come up with totally new constellation names. 250 years from now, a new island's on the map. Back in 2021, it was just an underwater volcano somewhere in the Pacific. After thousands of years of spouting out lava, it finally reached the ocean surface and busted out in the cool, fresh air. Not much growing on it yet. Niagara Falls has long since disappeared, and Lake Erie and Lake Ontario have teamed up to form one huge super lake. 300,000 years from now, the triple star system WR-104 is about to explode. It's spinning crazy fast, and there's a chance that radiation from the explosion could eventually reach Earth. That would do a lot of damage to all life on our planet. Voyager 1 reaches the brightest star in the night sky, Sirius. Not a very funny star at all, it's really Sirius. It's 8.6 light-years from Earth. 500,000 years from now, scientists are pretty sure that a huge meteorite could fall to Earth any day now. It might be even the size of 8 football fields. The impact of such a massive meteorite would cause an explosion so powerful that its sound would be heard on every continent. That would be followed by super strong earthquakes and tsunamis higher than the Brightside Empire municipal building tower thingy. Okay, I just made that up, but who knows what we'll be building in the future. 1 million years from now, the rogue star Gliese 710 comes very close to our solar system. We're surrounded by a huge shield of asteroids called the Oort cloud, and the rogue star is beginning to affect the asteroids hanging out in there. It grabs them, spins them around, and throws them toward the center of our solar system. Comets start to fall on our planet all the time, big ones, causing more tsunamis and earthquakes. 10 million years from now, the Red Sea is gradually expanding into the East African Rift. Africa is now divided in two by a new oceanic gulf. The human DNA molecule has completely decomposed. But it's no big deal. We've become totally digital, without any pesky aging problems. The really cool thing is that other animals have evolved a lot and changed ridiculously. Thanks to a simple interface, we're actually able to talk to dolphins, chimps, dogs, and cats. Turns out cats aren't grumpy, they're just busy contemplating life. 25 million years from now. The San Andreas Fault has been crazy recently and has caused the Gulf of California to flood the Central Valley. There's a new sea on the west coast of North America. 50 million years from now, Africa just collided with Eurasia. The Mediterranean Sea is totally gone. There's a new tallest mountain in the world. Its name? Mount Everest, of course. Australia's continuing its journey north. It already collided with Southeast Asia a few million years ago. The few human colonies still left on Mars need to do some serious packing. Phobos, one of Mars' moons, is beginning to orbit at a lower and lower altitude. That's not good. It's about 14 miles wide, so that's going to be unpleasant. 60 million years from now, the Canadian Rocky Mountains have completely eroded. It's just one gigantic flat plain. 80 million years from now, all that remains of Hawaii is one island. All the others have long since gone underwater. But just next door, a whole new chain of Hawaiian islands has emerged. Finally, 100 million years from now, we made it! The Atlantic shrinking down to nothing. The Americas are almost rubbing up against Africa. Africa's already merged with Eurasia. We've got ourselves a supercontinent again. Hello, Pangaea Proxima. All traces of human life are gone or buried deep underground. The movement of the continents has destroyed tunnels, roads, buildings, bridges. Animals and plants now reign supreme on Earth. So, where are all the humans? Well, remember we made the jump to digital about 90 million years ago? Things are still going strong. There are trillions of human minds living on a huge hard drive on a spaceship orbiting Earth. The super low space temperature is good for keeping the drive nice and cool. We have millions of different societies, languages, and cultures just like we had 100 million years ago. The only difference? We're all little ones and zeros in a huge digital universe that we created. And yes, there's still football.
These days, you're better off boarding a plane if you want to travel from New York to London. But what if I told you there was a time when these two cities were actually on the same continent? Well, the explanation is a bit more complex. For starters, back then, these two cities didn't even exist at all. But the tectonic plates they sit on today were a lot closer. Nearly 200 million years ago, all of the continents on our planet connected, making up one large supercontinent. This enormous piece of land was surrounded by one single ocean. We call this huge continent Pangaea these days. Some parts of this continent broke apart and shifted away from each other for our maps to reach their current configuration. There's even a nice experiment you can conduct to test this theory. Find a map online and print it on a piece of paper. After that, simply cut out all of the continents. Once you start playing around with them, you'll soon notice they all seem to fit together, like pieces from a puzzle. Probably the most striking thing you'll see is how South America perfectly fits Africa. What's even more fascinating is that this isn't the first time in our planet's history that supercontinents have been formed and then broken apart. Scientists have figured out that this happened at least 3 times before. And if we consider our planet's age, 4.5 billion years, the last 200 million is closer to the blink of an eye. So how did scientists figure out that continents move? Apart from the aspect of today's continents, they also looked at identical rocks, which have been found on different continents. They looked like they formed from the same minerals and under the same weather conditions. Some other secret helpers? Well, dinosaurs. Fossils from the same species have been stumbled upon in both South America and Africa. This particular dinosaur, named Mesosaurus, is said to have lived on our planet way before the continents drifted apart. It's hard to imagine how life on Earth must have been with one single continent. For starters, the climate must have been very different. That's because the mid-portion of the land would have probably been bone dry, having little to no source of water. More so, it was most likely hidden away behind many mountain chains. These would have acted as a barrier against moisture and rainfall too. However, geologists have also studied coal deposits from the United States and Europe. These seem to show that at least a part of the ancient supercontinent, which was close to the equator, must have been an amazing tropical rainforest, just like those we can find in the Amazonian jungle today. Coal appears when remnants of plants and animals get stuck into swampy water. If enough pressure is applied by the water, the substance is first turned into peat, then into coal. Our planet existed in this continental configuration for over 100 million years, and during this time, there was a lot of life on Earth already thriving. Hey, it was a great time to be an insect. Critters like beetles and dragonflies flourished. During the same time period, the Earth was roamed by the predecessor of all mammals, the synapsid. Life in Pangaea was severely hit during one not-so-great period. It's believed that a comet or asteroid landed on the surface of the Earth about 251 million years ago. The asteroid or comet theory seems to fit pretty well because 90% of all marine animals and 70% of the creatures living on land disappeared all of a sudden. The comet might not have been the only reason for the mass extinction. At the same time, there was also some important volcanic activity happening in northern Asia, which might have disrupted life on Earth. We may not notice it, but continents do continue moving as we speak. This configuration we now see with the help of satellite imagery will surely not be the last. Australia, for example, is slowly moving towards Asia. But the most important proof that our continents are still shifting is the eastern portion of Africa. This area is simply breaking off from the rest of the land. To witness this, you'll have to travel to one of the hottest places on our planet. But if you get to this piece of land on the eastern part of the African continent, you might sit on top of the exact spot that, soon enough, will be split in two by water. Underneath this region, 3 tectonic plates are slowly drifting apart. If the data is correct, in the far future, Africa will be split in 2, and between its 2 regions, a new ocean will arise. To support this theory, scientists have been closely studying a 35-mile-long crack in the Ethiopian desert for years. For this new ocean to form, it's estimated that 5 to 10 million years need to pass. Since our planet's crust is made out of multiple tectonic plates that are constantly moving, it's the perfect place to study this process. These plates are all irregularly shaped, and they are always mashing against, sliding under, or over each other. Those 3 tectonic plates found under the desert are also moving at different speeds. One of them, called the Arabian Plate, is sliding away from Africa at a speed of about 1 inch per year. The other 2 plates are moving a bit slower, somewhere between ½ an inch to 0.2 inches each year. More so, as these movements happen, material from deep inside Earth climbs to the surface and forms an oceanic crust at the edges. All this movement does make you wonder, how will the next supercontinent form, and when? So far, scientists came up with some possible configurations, each with its own name: Novo Pangaea, Pangaea Ultima, or Amasia. All these predictions still vary, as we're not sure how and why continents really move over time. One clue may be actually looking at how Pangaea separated in the first place. Regardless, it will take anywhere from 15 to 100 million years to see the next future continent, depending on each scenario. Novo Pangaea looks at the possibility in which present-day movements continue. In this scenario, the Atlantic Ocean will continue to expand, all the while making the Pacific smaller. The two American continents would first combine northward. Africa, Europe, and Asia will have already combined too, by the time they all meet together in one single huge piece of land. Another possible scenario is called Pangea Ultima. In this case, the Atlantic will slow down in its expansion and actually become a landlocked body of water. North America, Africa, Asia, and Europe would become somewhat parallel pieces of land, completely sewn together. Underneath them, South America, Antarctica, and Australia would complete the circle surrounding the North Atlantic. All the while, this piece of land would be surrounded by a large Pacific Ocean. Asia looks at a scenario that's a bit difficult to understand and study at this point. Since several tectonic plates look like they are moving north, it might be possible that all continents, apart from Antarctica, will slide completely toward the North Pole. The climate would be a lot different and way colder. Both the Pacific and the Atlantic, in this scenario, would remain open bodies of water. Scientists believe this to be a real possibility because of some anomalies left by Pangea deep in the Earth's interior in the part called the mantle. Looking even further into our planet's future, it's estimated that in about 1 billion years, the luminosity of the sun will be somewhere around 10% higher. As such, the atmosphere on Earth will closely resemble that of a moist greenhouse. Because of the added heat, all the bodies of water on our planet will start to rapidly evaporate. Moving further to 4 billion years from now, the temperature on our planet will soon transform it into a Venus look-alike. It might get so hot that the Earth's surface will begin to melt away.
Asteroid strikes, gamma-ray bursts, supernovae blasts, and other terrifying threats could potentially take out humanity. But one of them is inescapable, a cataclysmic event that will happen around 1 billion years from now and most likely rob our planet of its oxygen, effectively wiping out all life forms. Nearly 2.5 billion years ago, there was a period called the Great Oxidation Event. It gave us a breathable atmosphere, thanks to which we're all alive today. Cyanobacteria, also known as blue-green algae, appeared on Earth, filling the atmosphere with oxygen. It eventually led to the appearance of a world filled with multicellular life forms. But then, one of Earth's greatest die-offs occurred. It happened 450 million years ago. This event is known as the Late Ordovician Mass Extinction. Scientists think it might have happened because the inverse process took place. The level of oxygen on the planet dropped dramatically, and it lasted for several millions of years. It's unclear what could have caused such an extreme event. During this period, the continents formed one jumbled mass called Gondwana. Most life on Earth lived in the oceans, but plants were starting to colonize land. Near the end of the Ordovician period, a climate shift covered the supercontinent with glaciers. This dramatic cooling alone was enough to lead a lot of species to the brink of extinction. And then, oxygen levels plummeted, which caused the second wave of extinction. Scientists have found evidence of this event in seafloor samples gathered from all over the world. Some are sure that glaciers were responsible for changing the layers of the oceans, which had previously had unique temperatures and specific concentrations of elements like oxygen. However, the exact cause of the oxygen drop is still unclear. Whatever the cause, more than 80% of life on Earth disappeared during the Late Ordovician mass extinction. Could a deoxygenation event happen again? Some researchers draw an eerie comparison to today's situation. They say that climate change is already reducing oxygen levels in our oceans. It's likely to make loads of species go extinct and the world to change beyond recognition. Now, even if global cooling triggered the Late Ordovician mass extinction, what sparked this process in the first place? There's a theory claiming it could have been a gamma-ray burst. These bursts seem to be the most violent and energetic explosions in space, and they might be related to supernovae. Thankfully, we haven't seen such a burst close enough to fully figure out what it is. So far, they have only been spotted in other galaxies. If a gamma-ray burst occurred in our home Milky Way galaxy, it could also lead to a mass extinction on Earth. A burst pointed in our direction might only last 10 seconds or so. And still, it would destroy at least 50% of Earth's ozone layer. Yes, in such a short period of time. Even a relatively small amount of ozone depletion is enough to cause serious harm to our planet's natural sunscreen. And wiping out ozone on a large scale can wreak havoc, finishing huge numbers of species, starting with the ones living in the upper levels of the ocean. Gamma rays also break apart atmospheric oxygen and nitrogen. These gases turn into nitrogen dioxide, commonly known as smog. If this smog blanketed Earth, it would block out sunshine and trigger a global ice age. But our ultimate fate is much more dramatic than any of these scenarios. Most life on Earth will eventually disappear due to lack of oxygen after solar activity causes atmospheric oxygen to drop back down to the level it had been before the great oxygation event occurred. The sun ages and puts out more and more energy. At one point, around 1 billion years from now, Earth will reach the point where atmospheric carbon dioxide will begin to break down. That's when oxygen-producing plants and organisms will disappear. Earth won't have enough life forms to sustain the oxygen-rich atmosphere all living beings on our planet need. This process may take as few as 10,000 years, and it seems to be unavoidable. Luckily, we still have around 1 billion years to figure out how to save ourselves.
Imagine a world of seething hot metal where iron and nickel dance in a fiery inferno. This is the inner core, the heart of our planet. But what if this very heart was changing? The latest research suggests that the Earth's inner core may be slowing down and even reversing its rotation. Is this a sign of the end of times? Will the Earth come crashing down on itself? Let's find out. Imagine you have a giant onion, and every layer represents a different layer of the Earth. The center of this onion, the part you can never reach, represents Earth's core. It's like a mysterious land that no one has ever set foot on, yet scientists have been trying to uncover its secrets for centuries. Imagine diving deep into the center of the Earth, beyond the crust, the mantle, and finally, 1,800 miles below the surface, where you'd reach the inner core. It's a ball of seething hot metal made up of solid iron and nickel, and it's so hot it glows a brilliant white. It's also surrounded by a liquid outer core. This mysterious place is unlike anything else on our planet. And get this, it's spinning on its own axis. The inner core is like a fire tornado that's constantly swirling, generating heat and energy from the inside out. But why is it so important to study this little piece of the Earth? Well, it's responsible for creating our magnetic field. This magnetic field is important to study because it protects us from harmful radiation from the sun. It's created by the movement of molten metal in the Earth's outer core and the spinning of the Earth. These movements generate electrical currents, which then create the magnetic field. It's like a shield that protects us and helps us keep our planet healthy and safe. But there's still so much we don't know about the inner core. For example, how did it form? Scientists believe it started to solidify about 1 billion years ago. But why did this happen? What was the trigger? Or, for example, what about the inner core's crystal structure? It's thought to be a type of iron called hexagonal close-packed iron, but we still don't know if it's actually the case. In other words, we may have many theories, but unfortunately, there's no way to confirm them, at least for now. So how do scientists study the inner core if no one can go there? They use seismology. Seismology is like a sonic scanner for the Earth. You send sound waves through the Earth and measure how they bounce back to see what's inside. That's basically how we discovered the inner core way back in the 1930s. Imagine you're listening to the sound waves with your special seismology machine. Suddenly, you hear a strange sound like a ping. It's different from the other sounds you've been hearing, and you can't explain why. You keep listening and you hear the ping again and again. you start to realize that this ping is happening every time the sound wave hits the Earth's center. You study the data more and more, and finally, you figure it out. The Earth has a solid core. This discovery was a big breakthrough and helped us better understand what's inside our planet and how it works. Right now, scientists also use something like this to study what's inside our planet. When earthquakes occur, waves travel through the Earth and bounce off different layers, including the inner core. By studying these waves, scientists can learn about the inner core's properties, such as its density and temperature. They're basically solving a mystery by piecing together tiny clues. And every new discovery brings us one step closer to understanding it. The inner core is a unique and fascinating part of our planet. It's a place where the laws of physics work in different ways than they do on the surface. And it's a place where scientists are still trying to unravel its many mysteries. And here's one of them. For some reason, the heart of our planet is about to stop spinning. A new study about this was published in Nature Geoscience. It was made by the researchers at Peking University in China. It has revealed a huge twist. The scientists found that the inner core spin rate has slowed down significantly. It's something that no one expected, but according to the results of their study, the slowing down began all the way back in 2009. And that's not all. Their results also suggest that the inner core may be reversing its rotation. That's right, this hot ball of iron and nickel that has been spinning around for millions of years may be slowing down and changing direction. It's like when a spinning top starts to slow down, except this is happening in the center of our planet. Scientists have been puzzled over the discovery for quite some time now. So, what does it all mean? And why is this happening? Well, it turns out that there might be a larger pattern at play. The scientists believe that this change in the inner core's rotation may be due to the influence of Earth's mantle and the magnetic field of Earth's outer core. The mantle and the outer core are affecting the inner core, which is causing its spinning rate to slow down and potentially change direction. Before this study, scientists thought that the inner core was spinning faster than the Earth's crust. However, this new information suggests that the inner core may be slowing down due to the gravitational effect of the Earth's mantle and the magnetic field of its outer core. But here's where it gets even more interesting. When researchers took a closer look at data stretching all the way back to the 1960s, they discovered that the rotation of Earth's inner core was consistent from the late 1970s to the early 2000s. Before that, they found that another possible slowing down or reversal event may have occurred in the early 1970s. It's like the inner core spin is like a roller coaster ride, speeding up, slowing down, and possibly reversing course over a period of time. The researchers estimate that these switches occur every 7 decades or so, which is pretty wild. But why is it happening? Unfortunately, we still have no idea. The exact reasons for why the Earth's inner core sometimes stops and starts spinning in another direction aren't yet well understood. However, scientists believe that it may be due to complex interactions between the solid inner core and the surrounding molten outer core. A lot of different things can be at play here. The changes in the temperature, pressure, and composition of the core, as well as the movement of material within the core itself, and so on. Also, as we said before, the Earth's magnetic field and the gravitational forces from the surrounding mantle might also play a role here. We need further research to fully understand the mechanisms behind the inner core's rotation changes. So, is the world ending? Fortunately, no, not just yet. While the inner core is changing direction right now, it's not the end of the world as we know it. And even though findings may seem like a huge deal, life on Earth's surface hasn't been impacted much, if at all. In fact, it's just a fascinating part of the Earth's inner workings that we're learning more about every day. So, you can say with relief, nothing cataclysmic is happening. Moreover, according to Hervoya Kalsic, a geophysicist at Australian National University, the inner core is now more in sync with the rest of the planet than a decade ago when it was spinning a bit faster. All in all, this new study has added a strange twist to the story of Earth's inner core. and scientists believe that there's still much more to discover about this mysterious place. Who knows what other secrets lie in the heart of our planet? The possibilities are endless. So let's keep researching and enjoy our time on this amazing planet.
While we may think of ourselves as advanced after catching a glimpse of the 8 planets of our solar system and their 200 moons, we really have little idea of what's out there. So much so that there's speculation that there might be one more planet in our solar system. Scientists call it Planet X or Planet 9. This undiscovered world could be hidden way out past Neptune. Asteroids and dwarf planets in this area have weirdly unexplained altered orbits, and Planet X may be the reason. Tales of this mysterious planet began over 100 years ago with a man called Percival Lowell. Lowell had a great love of space, and aside from having an impressive mustache, he was also super rich. Ooh, that lucky guy. He used his riches to build an observatory in Arizona. He then dedicated it to study the odd motions of Uranus and Neptune. Their gravitational pulls are slower than those of all the other planets in our solar system, almost as if there is a giant hidden object pulling them off course. In 1906, Lowell theorized that there could be another planet out beyond Neptune. It probably caused those strange cosmic happenings. The man called this potential space body Planet X. In 1930, Pluto was discovered by Clyde Tombaugh at Lowell's very own observatory. It finally looked like people had an explanation for the weird orbital patterns. Lowell's team was on cloud 9 after the discovery, but their celebrations were short-lived. Soon, they found out that Pluto is way too small to be having that much of an effect on the surrounding planets. And it was also too far away from them, so it was back to the drawing board. Planet X, if it exists, is 10 times the size of Earth and 4 times its radius. It would take at least 10,000 years for the planet to orbit the Sun, and it would sit over 200 times further out than our home planet. That's 600 astronomical units from the center of the solar system. FYI, an astronomical unit equals the distance between the Earth and the Sun. But while that sounds super far away, it's actually not. The distance between space bodies is usually measured in light years, and an astronomical unit is a much smaller unit of measurement. For context, the most distant thing detected from Earth is the galaxy GNZ11. Cute name, huh? It sits a staggering 32 billion light-years away. Even so, our telescopes can still spot it, and just 1 light-year is the same as 63,241 astronomical units. Woo! So, if our tech can detect a galaxy that's so far away, how have we not been able to uncover Planet X? Well, it's probably down to the fact that it might not even exist. The theory of Planet X was pretty much debunked back in 1989. It was discovered that the mysterious gravitational pulls of Neptune had been a red herring all along. Scientists had massively misjudged just how big Neptune actually was. Voyager 2 visited the planet and discovered its actual size. This new info explained the odd gravitational pulls, meaning they weren't being caused by the so-called Planet X. But that's not where our investigation ends, as the hypothetical 9th planet once again popped up around 10 years ago. While the evidence behind Lowell's theory was wrong, his belief in Planet X may not have been. In 2015, astronomers Michael Brown and Konstantin Batygin discovered that there were, in fact, unexplained gravitational forces at play past Neptune. There are satellites that orbit planets perpendicularly, which doesn't happen anywhere else in our solar system. There's also clusters of asteroids that move in very specific ways, so specific that it's basically impossible that it could be random. Even weirder, there are satellites that travel in completely opposite direction to the Sun, unlike most other things in the solar system. A planetoid called Sedna also appears to be being pulled towards something, along with 6 others, all going in the same direction. And Brown and Batygin aren't just any other stargazers. They're both well-respected scientists at the top of their game. Konstantin Batygin has been named in Forbes as one of 30 scientists who are changing the world. And Mike Brown was the man who rebranded Pluto as a dwarf planet. This means that when these guys say something, it's usually pretty legit, and you should probably listen. But the only way we can really prove Planet X exists is to actually find it, and this has turned out to be pretty difficult. To locate the planet, we'd need to use a method called transit photometry. This is basically where we monitor a whole bunch of stars for a long time and look out for any dips in the light they give off. These dips would likely be caused by a planet getting in the way, and ta-da! The existence of Planet X could be proved. But for this method to work, Earth, the new planet, and the Sun all have to be perfectly aligned. These circumstances are pretty rare, and if these conditions don't exist, the dip in light won't happen. Plus, this method would only really work with planets that are closer to the Sun than our Earth. That's Venus and Mercury. For anything past Earth, this technique is pretty much useless. Another technique we could use is to find the potential planet through a good old-fashioned telescope. But as you can imagine, that's insanely tricky. The furthest object that we've found in our solar system is a planetoid appropriately named Far, Far Out. But that's only 140 AU away from the Sun. That's only like a quarter of the way to Planet X. We can only see an object because of its brightness. The Sun is very visible to us because it emits huge amounts of light. And we can see the Moon because it reflects the Sun's light. Technically, the Moon has no right to appear brighter than everything else in the night sky. It only seems brighter because we're closer to it. The farther away an object is, the less bright it appears to us. The major issue with seeing the theoretical Planet X is that all objects in our solar system get their light from the Sun. They reflect sunlight, and that's why we can see them. Given how far away from the Sun Planet X might be, it makes it nearly impossible to see. And because of its really dim light, to view it, we would require perfect weather conditions as well as an extremely strong telescope. But Brown and Badigeon have found the perfect one. The Subaru telescope is located at the top of a dormant volcano in Hawaii. It's huge and is capable of capturing even the weakest light from distant space objects. The issue that we need to figure out is where to point it. Without knowing where Planet X actually is, this basically turns things into a giant guessing game. There are also only around 3 nights every year when the conditions are clear enough to see the hypothetical Planet X. It's difficult, but not impossible. And still, most astronomers have called it a day and agreed that Planet X doesn't exist, stating that it's just a common myth. The most widespread explanation for the weird gravitational pulls is that there's a tiny black hole in our solar system. It's pulling the planets toward us. But don't worry. They say it's not big enough to actually munch on a planet. So Earth is all good, for now. The issue with the black hole theory is that, once again, it's almost impossible for us to track the thing down. While its mass could be as great as that of Planet X, the hole itself would be squished down to the size of an orange. Telescopes wouldn't be of any use. To find it, people would have to look for the gamma rays sent off by objects as they fall into the black hole. Another way we could find it is to release hundreds of tiny spacecraft. They would pass close enough to the hypothetical hole, and when they got pulled toward it, we could probably detect it. But don't count out Brown and Badigeon's theory. It's still being documented by NASA. And until we find unmistakable evidence to prove any theories, Planet X might still be out there.
Your car breaks down in the middle of the highway and won't start. A friendly driver pulls over nearby and gets out some jumper cables connecting your car to his. A few sparks, and your car comes back to life. And that's how life began on Earth. Sort of. There's a theory that life was jump-started on Earth like this billions of years ago. It all started with clouds in the sky. We've all been there, sitting by the window on a rainy day. You wanted to go out and have fun, but the rain pouring outside made you want to stay in bed and snuggle. Still, the lightning and thunder are keeping you awake. With nothing better to do, you think about how lightning even forms. Like I said, clouds, and many other things. You see, when a storm occurs, cold air and warm air meet. The warm air goes up to create thunderstorm clouds, which produce droplets, and the cold air below has ice crystals in it. During a storm, the droplets and crystals have a little mosh pit and move all around. All that bumping and grinding creates electrical charges in the clouds. If you ever replaced batteries on a remote, then you've seen a plus and minus sign on either end of the battery. The plus is where the positive charge is, and the minus is home to the negative one. And just like batteries, clouds have their own plus and minus. The positive charges are kept at the top, and the minus is, you guessed it, at the bottom. So when the charge at the bottom generates enough power, the cloud lets out energy. As the energy travels through the air, it seeks out positively charged objects, like a pole or a tree. And when it finds it, the energy is released and lightning strikes. These bolts of lightning can hit anything on the ground or travel from cloud to cloud. And thunder occurs because of the hot and rapidly expanding air. So, billions of years ago, the Earth wasn't quite like today. Thunderstorms were a lot more frequent than now, and life was still in its beta phase of things. These lightning bolts may have been the key to kickstart life by producing one of the most important minerals for life, phosphorus. DNA, RNA, and cell membranes wouldn't exist without it. It's essential in all stages of our life, from growth and mobility to reproduction. Everything that makes up who we are is in our DNA, those twirly things with proteins latched onto them. So what do lightning bolts and phosphorus have to do with each other? Does phosphorus flash in the sky whenever a thunderstorm happens? Not really. When lightning strikes the ground, it creates something called fulgurites, or in English, glassy minerals fused in the heat caused by the lightning. And when they appear, they take on the shape of the lightning bolt when it strikes the ground. Some new studies suggest that fulgurites could release phosphorus when dissolved in water. When doing so, phosphorus is able to form biomolecules, which help in forming life. Back then, volcanoes were also pretty big on erupting frequently. So, with ancient hot springs, you'd expect lightning to strike down nearby and produce fulgurites next to those hot sources of water. Scientists were able to estimate that during the early days of Earth, 1 to 5 billion lightning flashes were able to occur. So, in the next billion years or so, we can expect 1 quintillion lightning strikes. Yeah, that's a lot of zeros. With all those flashes and strikes, phosphorus was able to grab its chance to start life when dissolved in water. And of course, not just phosphorus, but a mix of many chemicals and minerals were needed to perfect this recipe. Another theory on how life began on Earth starts all the way in outer space, far away from our little blue planet. Flying through the vastness of space were meteorites. Life on Earth began roughly 4 billion years ago, and these meteorites were busy flying all over the place, with many of them hitting Earth in its earliest shape. Scientists claim these meteorites carried chemicals essential to creating life. Some of those important ingredients were carbon-based compounds, including sugars and amino acids. And they needed wet and dry cycles to bond on a molecular level to finalize the process. So once life was injected into Earth, we got to see the first organisms that were around 3.7 billion years ago. Keep in mind, there wasn't much oxygen floating around or in the water compared to now. But these microscopic organisms, or microbes, left their mark with a certain carbon molecule produced by living things. But life as we know it today wouldn't happen without oxygen, that invisible element that keeps everything alive. So around 2.4 billion years ago, these microbes began changing and became Earth's first photosynthesizers. They made their lunch and dinner using water and the sun rays while releasing oxygen in the process. With many of these new organisms, the rise of oxygen made the environment harsher for microbes, but it was starting to become the baseline for life's groovy track. A new party popped out for those who could dig oxygen. You see, mammals and other organisms have multiple cell types: bone cells, skin cells, muscle cells, you name it. These microbes were single-celled organisms, so with the rise of oxygen, many of these microbes began moving in with other microbes. I don't mean being roommates in a shared apartment. They actually merged with other microbes to become multi-celled organisms. Pretty clever, huh? Fast forward a couple billion years, and we have some of our first animals to ever exist. So actually, around 800 million years ago, the oxygen levels in the ocean and seas still weren't as high as they are today. But one of the earliest creatures on Earth were sponges. Scientists were able to determine this by studying DNA on rock samples dating back to when sponges first appeared. They also claim that sponges sped up the rise of oxygen levels by eating bacteria, removing them in their decomposition phase. Then, around 580 million years ago, more creatures began to appear. The oxygen levels were starting to be acceptable for life to flourish, and many other bizarre-looking creatures inhabited the ocean floor. Even the oldest kind of jellyfish were around. They looked like tiny aliens from another planet. I wouldn't want to find any of those in my drink. And around 40 million years after the end of that period, many of these strange creatures began to disappear. It was then that scientists were able to find evidence of worm-like creatures that were able to burrow in the ocean floor. This is probably one of the first signs of evolution for survival. Then, around 530 million years ago, evolution cranked it up a notch. There were many new creatures out there with new and never-before-seen body parts. Shells and spines and other body parts allowed some of these new animals to further survive and burrow their way around the ocean floor. And shortly after, a couple of million years, the first true primitive vertebrae appeared in something that looks like an eel. This was the creature with the first backbone. Over the next million years, many of these animals began to form skeleton-based and cartilage bodies. And after much splitting, amphibians appeared, and four-legged animals began to walk the Earth's surface. It's also worth noting that there were many mass extinctions that happened along the way. But in the end, life kept evolving. And with many plants and animals emerging, the landscape was changing in the process. Many natural disasters occurred along with ice ages that froze the land and seas. To add to the overall chaos, plenty of volcanic eruptions and earthquakes continued to change the look and landscape of the Earth. The first primates emerged around 4 million years ago, and ever since then, apes and monkeys began to branch out into their own category until humans eventually came into the picture. By understanding these theories, scientists are able to observe other planets with similar conditions. We could actually witness the birth of life on another planet. Of course, this would take billions of years to happen, but I wouldn't want to miss it.
You're relaxing in your room and streaming some good tunes when suddenly the network's down. You try rebooting your phone, but there's still no connection. Out of nowhere, your sister barges into your room in panic. She's screaming something about rings. Boxing rings? Wedding rings? Rings on the tub? She's not making any sense. So she drags you out of the house and shows you the sky. You take a look up and see streaks of objects forming miles above the Earth's surface. Her connection seems to work. The two of you check online what's going on, and everywhere the same thing is making headlines. Rings are suddenly appearing in our sky. Hashtag #EarthRings is breaking the record, and videos are going super viral. Your sister can't help but join the crowd and takes a bunch of selfies with the sky. You run to the TV in your living room to check out the news. Scientists are warning about a coming catastrophe and explaining that everyone should remain indoors. Even though it's a cloudless day in the middle of summer, the weather seems to be getting colder and colder. Suddenly, the signal's cut off. Other channels show nothing either. Then you see your neighbors packing their bags and heading out. Others follow suit. You hesitate a bit, but decide to do the same in the end. Your sister is still outside taking selfies when you urge her to come along with you to seek some answers. The two of you hop in your car and drive out into the city. The rings above seem to be gaining more mass with each second. You and your sister are getting colder and colder. You head to the university to see if anyone knows anything, but there's no one there. Only one parked car in the lot. And it's a good thing you recognize that car. You and your sister rush in and find the astronomy professor doing some quick calculations and trying to figure out why all this is happening. He urges you to take seats and begins explaining. No one knows what this is all about, but it's limiting the sun's exposure on Earth, which explains why it's getting colder by the minute. Why the rings are getting thicker is a mystery too. On Saturn, the rings are made up of ice and rock particles. They can be as small as an ant or the size of a bus. The rocks could be leftover meteor debris or even remnants of dwarf planets. But since Earth is so close to the sun, ice wouldn't be something you'd find floating above us. With all these rocks piled up, they block the Earth's access to sun to warm us up and give us light. The professor goes on to explain that Earth will enter a new ice age, and oxygen levels will deplete within a year's time unless those newborn rings disappear anytime soon. This also explains why there's no connection. The rocks that form the rings are hitting and breaking the satellites. Suddenly, you hear a loud ringing noise outside. The three of you head outside and see a helicopter blasting an alarm with a red light flashing.
Everyone to your homes now. This is not a drill. Everyone, head home.
You get in your car with your sister, but the roads are jammed. You have to go on foot, which will take 2 hours. There's no way anyone can remain outdoors. You venture out seeing everyone stuck on the road. They're all arguing with each other and causing chaos. You try not to get caught in the middle of anything and sneak your way to the highway. With the rings getting thicker, less sunlight is breaking through. This Ice Age info is stuck in your head, chilling you even more. You take a deep breath and see a thin mist coming out of your mouth. The sky is getting darker and you're still not home yet. Your sister is tired and needs to rest, but you urge her to move on. You find an abandoned clothes shop and head inside. The store clerks are actually giving away thick jackets for everyone to wear. You grab a couple and slip them on. Only 1 more hour to get home, but the sky is completely dark. There's no way you and your sister can go out in such conditions, so you decide to camp up in the clothes shop. They set up a mini bonfire in the middle of the shop and create makeshift sleeping bags with the rest of the unused clothes. Luckily, there's enough food to feed everyone, including you and your sister. It's the middle of the night. The fire goes out, and you can't see outside the shop. You head to the window and open it up. A huge pile of snow spills in and wakes everyone up. It's the middle of August, and a snowstorm formed overnight. Everyone is freezing, and they start the fire anew. There's no radio or any way to find out what's happening. The wind picks up and starts shaking the shop. Things start falling off the shelves, but you and everyone else are cozy by the fire. The next day, you look outside and see the entire area covered in snow. You live in a sunny place where it barely rains, and the rings in the outer atmosphere are even bigger than last night. Out of nowhere, a truck filled with people pulls over, and the driver tells you there's a shelter for everyone some miles away. The truck has chains all over the tires and is equipped for the worst snowy conditions. Even though it's morning, the sky is pretty dark. You and everyone else hop in. Abandoned cars, some with their doors still open, are scattered all over. The truck drives around them or just smashes through the ones in the way. It pulls over next to an ambulance and takes all the equipment to help the ones in need. You drive past your neighborhood and see your entire house covered in snow. The large tree in your backyard has fallen under the weight of the snow and broken the roof, allowing snow to flood in. The truck speeds through and gets to the shelter, which, to your surprise, is the mall. You get out and see many of the townspeople being led to various stores that have now turned into dorms and health units. You're left in a sports store with a bunch of other people. Your sister has also been able to bunk with you, and to your luck, you see the professor helping out some people. But shortly after that, a loud explosion blasts through the mall and shatters glass screens. Everyone ducks for cover. You see people running outside. You head out and see a large metallic object lying in front of the mall entrance. There are people crowding the entire area, so it's not easy to see what all the fuss is about. But after getting a closer look, you find out it's a satellite fallen from orbit. It crashed in the front yard and made the boom. There were also reports of other satellites crashing on Earth in the most random places. That means all communication has been wiped out of the map. You run back inside the mall to await what happens next. You look at your sister in fear, not knowing that the new Ice Age has just begun. One year later, you're relaxing in your bunker when your sister barges in, freaking out. The rings are still there, but it's something else now. You run outside and see everyone gathering around and looking at the sky. Within a year, temperatures have dropped to freeze the entirety of the Earth's surface. Deserts and tropical jungles have turned into icy wastelands. More than half of the wildlife went extinct, and trees are as rare as a four-leaf clover, which means oxygen levels have dropped significantly. Most of the population, or what's remaining of it, live with oxygen tanks, with scientists still trying to crack the case of the rings. Exactly what the professor predicted. But up in the sky, rocks seem to be falling down and crashing all over. It starts off far away, but then the rocks begin to fall down close by. You and everyone else run back into the mall, which has been covered with a layer of metal to keep the warmth inside. It should be pretty safe in there. If the rocks are falling down, that means the rings are dissipating. Suddenly, you're full of hope that the ice age might be over soon.
You wake up with a start, open your eyes and look around. Oh, you're inside your sleeping capsule. Its walls are littered with different buttons and tiny screens. You press one of them, and one of the sliding panels sweeps to the side. You crawl out of your pod and start another regular day on the moon. Or maybe you open your eyes and come up to the window to have a look at the weather outside. Everything seems to be as usual: blue trees, purple sky, and low-hanging yellowish clouds. Great, you won't need your acid rain protection today. Or maybe you'll open your eyes to the dry plains of the red planet. You'll eat your 3D printed breakfast and set off on a trip to Olympus Mons, the largest volcano on Mars. You've been planning this climb for ages. Whatever scenario it is, one thing is glaringly clear: you're not living on Earth. Why? There might be a few reasons why people could have abandoned our beautiful green paradise. The sun might have grown too old and started to expand, burning vegetation, boiling the oceans, and leaving Earth uninhabitable. Or it was probably a collision with the Andromeda Galaxy. Yes, the one that is bound to crash into the Milky Way in about 4.5 billion years. It could have been a wandering asteroid, large enough to destroy all kinds of life on our planet. Of course, these days, astronomers have their own ways of spotting such space intruders. But what if their equipment malfunctioned? It would end badly for Earth and Earthlings. A much sadder reason for us to leave our beloved planet would be our own actions and the risks we pose to it. According to statistics, these days, the onslaught of droughts, earthquakes, floods, and epic storms is triple the number from the 1980s and almost 54 times that of 1901. Climate change could lead to water shortages, a severe lack of food, and the submersion of coastal regions. If it all went too far, we'd have to conserve the planet to save at least some of its flora and fauna. Then, it would become a nature reserve the remaining people would sometimes visit. But if not on Earth, where would humanity live? Surprisingly, there are quite a few options. For example, we could dig several feet beneath the surface of the moon and build our bases there. Or the first towns on the moon might be built in craters and covered with protective materials, like plastic reinforced with a net made of titanium and UV-resistant superfiber. The inhabitants would have to access their homes through airlock entrances dug into a mound. Or we could skip the moon altogether and set off towards the moons of Jupiter, Saturn, Uranus, or Neptune. Yes, they're much farther from the sun and probably way too cold for us. But on the bright side, these moons are believed to contain vast amounts of water, carbon, and nitrogen. And still, the most likely destination is Mars. Unlike the moon, which has a very, very weak atmosphere that consists of unusual gases, Mars has a bit denser atmosphere, even though it's still about 100 times less dense than the atmosphere of our home planet. In any case, it can offer us some protection against harmful space radiation. Mars also has about 40% of Earth's gravity, which is not that bad. We could probably get used to it with time. Plus, there's water ice on the red planet. The soil there contains enough carbon to grow plants. With time, the planet could be terraformed with the help of water from underground ice or imported from an ice asteroid. We'd use this water to form a thin ocean and maybe even create a breathable atmosphere. Or we could find an exoplanet that has all the resources to support life. An exoplanet is a planet outside our solar system. it would probably be much easier for us to find a world that would be perfect for us, rather than reconstruct the already existing world with its own workings.
Traveling back in time now, this used to be hard. We fly past the Middle Ages, the first human civilization, the ancient ancestors of the first humans, the dinosaurs, the first land animals, the ancient sea creatures, and so on to the very beginning of all time. And there it is! This nebula is our solar system. Right now, it's just a cloud of multicolored dust made of hydrogen and helium spinning around. This cloud has begun to shrink and become denser. There's a theory that there were supernova explosions near our nebula. Their shockwaves squeezed the nebula from different sides until the center of the cloud became too heavy. The enormous weight presses it, and nuclear chain reactions begin at the very center of this cloud. It heats the cloud and makes it glow. Soon it forms into a dense sphere, and that's how our sun is born. It happened about 4.5 billion years ago. Our planet doesn't exist yet. There's only a disk of dust and space debris orbiting the young sun. These pieces of debris are fusing gradually and getting heavier and heavier. Let's look at the very center of this pile of asteroids. The total weight of the debris compresses the central region so much that a dense metallic core is forming there. The enormous pressure heats the core, and the temperature at the center of the young Earth reaches nearly 10,800 degrees. And there's a liquid core around the solid one. It creates the magnetic field of our planet. Now, when radiation from the sun and the solar wind reaches Earth, it smashes into a shield in the form of our magnetic field. So far, our planet is burning and looks more like a ball of lava. But it begins to cool down, forming a solid crust. At this point, another protoplanet appears on the horizon. It looks more like an asteroid, the size of Mars, and this massive piece of debris flies towards us. It hits the young Earth at such an angle that it knocks a part of our planet outward. The debris itself breaks into several pieces and stops in our orbit. After a while, all of this debris comes together to form the Moon. As a result of this collision, the Earth began rotating too fast. A day now lasts about 5 hours instead of the usual 24. But the Moon is heavy enough to slow our planet's rotation with gravity. Now, the Earth doesn't look like a hospitable place. The gravitational forces of the Moon are penetrating deep into the Earth and causing more volcanic activity. Also, meteorites are constantly falling here, causing frequent explosions on the surface. Ow! The gas that comes out of the volcanoes forms our atmosphere. The ice that was brought to our planet on meteorites evaporates. The vapor rises and turns into rain. This rainwater falls to the surface, cooling the hot lava and forming the first lakes and rivers. For several 100 million more years, Earth resembles the surface of Venus. It's a lifeless place with a bunch of volcanoes, acid rains, and no oxygen to breathe. The sun wasn't as bright as it is now. Plus, the sun's rays could barely pass through tons of volcanic dust in the atmosphere. But about 3.5 billion years ago, the first life appears here in the form of single-celled organisms that didn't need oxygen. They appeared in the shallow, warm parts of the ocean near the shore. These bacteria reigned on Earth for nearly 2 billion years throughout the Archean eon. They left stromatolites. These are stone pillars at the bottom of shallow, warm water. They're the product of simple organisms and bacteria. These bacteria evolved until they learned photosynthesis. Bacteria began to produce oxygen by absorbing the energy of sunlight. At first, this oxygen was spent on oxidizing rocks, but then excess oxygen began to fill the atmosphere. Plus, at this time, the first algae appeared, which also produced oxygen. This event is called the Great Oxidation Event, good name, which caused almost all living organisms to disappear from the face of the Earth. For simple organisms, oxygen was toxic, and the remains of bacteria and microorganisms sank to the bottom of the ocean. Many millions of years later, these remains will be recycled, and under the tremendous pressure of water and the Earth's crust, they will turn into oil. The Archean eon ended with this catastrophe about 2.5 billion years ago. At the same time, continents were forming on Earth, which would later drift through the world's oceans like puzzles and form a supercontinent. But for now, methane and carbon dioxide still make up most of the atmosphere. They cause the greenhouse effect and the rising temperatures on Earth. But the emergence of oxygen stops the greenhouse effect, and the temperature on our planet drops. An ice age, the so-called Huronian glaciation, which lasted from 2.4 to 2.1 billion years ago, begins. Scientists speculate that our planet was almost completely covered in ice at that time, even on the hot equator. A huge change when you consider that 2 billion years ago, our planet was like a ball and lava, but now it's like a block of ice. Earth, during the Huronian glaciation, was more like Jupiter's satellite Europa. There, too, is a thick crust of ice, under which there's a liquid ocean heated by the core. The evolution of the Sun saved our planet. Since its birth 4.5 billion years ago, it's been getting bigger and hotter. So, after 300 million years of an ice age, the Earth began to warm up. But almost all life there had been wiped out, and evolution has to start all over again. About 1 billion years ago, all of the continents of our planet were assembled into one hypothesized supercontinent, Rodinia, and all the oceans made up one colossal ocean of Miravia. 750 million years ago, that continent broke apart and huge chunks of land began drifting across the planet. Complex plants and multicellular organisms appeared just at this time. Algae, sponges, and fungi weren't the only inhabitants of the ocean. This is Sprigina. They're a kind of worms the size of a human finger. We have remains of these animals that are at least about 550 million years old. 541 million years ago, the Phanerozoic Eon began. The main event at that time is the Cambrian explosion. Life began to blossom on Earth, and a great variety of living organisms appeared. Mollusks and echinoderms like starfish and sea urchins appeared. Living organisms evolved, having not only an internal but also an external skeleton, like trilobites. Some of these things could reach nearly 3 feet in length. Their protective shells suggest that there were predators in the ocean. A food chain started forming at that time. At the same moment, the drifting continents fused again. This supercontinent has a different shape and is called Pannotia. Later, these continents drifted apart again and began to collide with each other. This led to the formation of mountain ranges. Then the continents met for the last time and formed the giant supercontinent Pangaea about 335 million years ago. Here we can already see the outline of the modern continents of Africa, North and South America, Australia, and Eurasia. One of the largest sea creatures ever, the Dunkleosaurus, appeared. Some individuals could be as long as a school bus and weigh as much as a large SUV. The land had a hot and humid climate. It encouraged ferns and other plants to grow faster. Some of them could reach the height of a 3-story building. And for the first time in Earth's history, some animals leave the ocean and go on lands, such as L. generpeton and Ichthyostega. Anyway, at first, they live only on the coast because their skin wasn't adapted to the constant sunlight. In addition, they experience breathing problems. The first animals on land had both gills and lungs, but the lungs were underdeveloped, so they had to return to the water. Millions of years later, these animals evolved into more advanced amphibians. Though they were no bigger than ordinary lizards, they could already live fully on land. But this blossoming of life ended in a new ice age. Glaciers from the poles slowly crept toward the equator. Animals weren't prepared for this, and most of them didn't survive this extinction event. But 290 million years ago, evolution retook hold and more evolved land animals began to appear. Gradually, they increased in size, multiplied, and gave birth to a new species like Scutosaurus and Gorgonopsis. But this period didn't last long either. Only 40 million years later, as a result of unknown events, 95% of all living organisms on Earth ceased to exist. It could have been caused by a giant meteorite or by increased volcanic activity. Also, one hypothesis says it could have been the release of methane from the bottom of the ocean. The Mesozoic era began after this extinction. This is where the dinosaurs, as we know them, appeared and started a new page in Earth's history. So get this, the Earth acquires 40,000 tons of mass every single year. More and more people are being born, new buildings and structures. You might think that's something that adds mass, but nope, since it's created out of existing matter on the Earth, it's actually dust falling from space to our planet. That dust consists of vestiges coming from our solar system, like space bodies that never managed to form into a planet, or asteroids and meteors that fell apart on their way and now drifting around. Our planet is there like a giant vacuum cleaner that pulls in all those particles of dust powered by gravity. So yes, Earth gains weight, But some calculations also say the entire planet, including the atmosphere and the sea, is losing around 50,000 metric tons of its mass annually. Gases like hydrogen and helium are within our planet's atmosphere, but they're so light gravity can't retain them there. So huge amounts of those gases escape our planet every year, 6 pounds of hydrogen every second. Sounds like a lot, but the Earth is really heavy, so it would take trillions of years for all the hydrogen to escape our atmosphere. Also, the planet's core is like some sort of big nuclear reactor. It runs all the time, so it gradually loses energy, which means it's losing mass too. Our planet is not a perfectly shaped sphere, it's more like a squashed one. As it spins, gravity is directed toward the Earth's center, while a centrifugal force goes outward. Earth has a tilted axis, so centrifugal force doesn't exactly oppose gravity. Also, gravity pushes those extra masses of Earth and water up at the equator into a bulge. Earth also has a waistline, 24,900 miles. You weigh more standing at one of the poles than at the equator. Although, for weight loss, Pluto comes as the best option. A 150-pound person would weigh around 10 pounds there. Avoid Jupiter, the same person would weigh over 350 pounds there. Our planet is all green and blue now, but chances are it used to be purple. Scientists think ancient microbes might have used some other molecule to harness the sunlight instead of chlorophyll that gives plants their green color. That molecule possibly colored the living organisms into a more violet shade. The Earth is electric. Just one stroke of lightning can heat the air to over 50,000 degrees Fahrenheit, which causes the air to rapidly expand. That same ballooning air makes a shock wave we know as thunder. 6,000 lightning flashes appear all over the planet every minute, and the longest one occurred in the sky above Brazil, 440 miles long. Newer studies found out that the Earth's core is as hot as the Sun's surface, over 9,300 degrees. The driest spot we have is the Atacama Desert of Peru and Chile. The center of Atacama has spots where we've never recorded any rain. The coldest place is naturally Antarctica, where winter temperatures can go down to minus 100 degrees Fahrenheit. No thanks. It's also the biggest desert we have on Earth. We imagine deserts as endless, sandy, and insanely hot areas, but there are coastal, subtropical, and polar deserts. They all have windswept and barren lands, which makes them very difficult for animals and plants to inhabit. The Pacific Ocean is the Earth's biggest ocean basin, which covers a huge area of almost 80 million square miles. The Pacific contains over half of the free water on our planet, and is so big all of our continents could fit there. Earth used to have 2 moons, or at least that's something scientists believe. That second one was almost 3 times smaller than the one we have today, and may have orbited our planet before it slammed into the bigger one. This clash may be an explanation of why the 2 sides of the moon we're left with is not equal. And there are moonquakes going on. It looks pretty inactive from our perspective, but the ground there is definitely shaking, although less than on Earth. Moonquakes shake at great depths, especially midway between the lunar center and its surface. To get to the longest mountain chain, we have to look way down under the surface of the Atlantic Ocean. It's a chain of volcanoes that goes about 18,000 feet above the bottom and spans over 40,000 miles. We have a magnificent planet, more than 4.5 billion years old, which makes it 10,000 times older than humans. But it's not the same as it was in the beginning. The ground we walk on is recycled. Earth has its cycle. Magma from the depths of our planet comes up and hardens into rocky matter. Tectonic movements brings the rock to the surface where erosion happens. That's a process where wind, water, and other natural forces break apart rock and changes it. Those small pieces get buried, deposited, and compacted into sedimentary rocks, like sandstone. If these rocks are buried deep enough, they get cooked and transformed into magma. So the whole cycle repeats all over again. We got used to seeing lava and ash coming out of volcanoes, but some of them even produce their own flashes of lightning. In 2020, the Taal volcano, which is around 40 miles away from the Philippines' capital, Manila, started blasting smoke and ash pretty high into the air. Inside its ash column, small pieces were colliding and then producing lightning flashes people could see scattering across the sky. Lakes can go crazy and explode too. Neos, Manoon, and Kivu are 3 lakes that sit above volcanoes. Since there's magma under their surface, there's carbon dioxide released into the lakes, which leads to a deep gas layer above the lake bed. It's pretty rare, but carbon dioxide can suddenly erupt from the lake and form an unpleasant gas cloud, similar to something a volcano does. 70% of our planet's surface is covered in oceans, but we've only explored 5% of them. And around 300 million years ago, I wasn't around then, we only had one massive supercontinent called Pangaea, with one huge sea, Panthalassa. Surprisingly, coral reefs are the biggest living structures. They consist of small coral polyps, but together they make a true community of organisms and a very important part of Earth's ecosystem. Some coral structures can even be seen from space. The Earth's surface is not evenly shaped, which means mass is uneven too. That way, gravity is not the same in all spots on Earth. There's a mysterious anomaly in the Hudson Bay of Canada. The gravity there is lower than in other regions surrounding this area, and scientists believe it's because of melted glaciers. During the last ice age, that region was covered in ice, which is now long gone and melted. But the planet hasn't completely recovered from the icy burden. Gravity over any area is proportional to its mass. The glacier left an imprint that pushed aside a part of the planet's mass, which is one of the reasons why the gravity is weaker in that area. Some bugs get nastier when in space without gravity. Studies showed some bacteria, like Salmonella, can make worse damage in space because there's something in the lack of gravity that makes them tougher and changes their activity. The days on Earth are slowly getting longer. When the planet was formed, days were about 6 hours long and gradually got longer. 620 million years ago, a day lasted 22 hours. Today, we have 24 hours, but it's increasing by around 1.7 milliseconds every century. This happens because of the Moon. It's slowing down our planet's rotation with the tides it helps create. When the Earth is spinning, tidal ocean bulges are pulled a little bit ahead of the Moon-Earth axis. That makes some sort of force that slows down the rotation of our planet, which is how our days are getting longer, but really slowly. We'll have to stick to our 24-hour schedule for a very, very long time. Earth's core certainly seems to be far away from us, but the distance is not that big, 1,800 miles. That's shorter than Route 66. The strongest earthquake we ever had was in Chile, a magnitude 9.5. If an earthquake ever reached magnitude 12, it could split our planet in half. Also, if there's an earthquake happening, it can hit more than 400 miles under the surface, which is why people on the other side of the planet can literally feel that. Our planet has around 100 million times more individual viruses than there are stars in the universe. Clouds are not some fluffy things whose shapes we sometimes like to watch. They actually help regulate the temperature of Earth. If we could pull out all water droplets in clouds and bring them to the surface, that would cover the planet with a liquid film as thick as a human hair. And yet, such a small amount of water brings enough differences with the weather and climate. Our planet would be 13 degrees hotter if it weren't for clouds. You know, rotation is a funny thing. Not haha funny, but kinda strange. Not only can't you feel it, everything does it. From galaxies to atoms, the universe is taking us for a spin. Strangely, it was more difficult to prove that the Earth is rotating than it was to prove that the Earth is revolving around the Sun. Way back in 1610, Galileo, the father of experimental science, provided the first proof that Earth, and all the other planets, revolve around the Sun. Galileo showed in his telescope that Venus was going through phases like the Moon. The only conclusion possible was that Venus was revolving around the Sun. Case closed. Planets revolve. But it wasn't until 241 years later, March 31, 1851 to be exact, that Leon Foucault proved that Earth was rotating. Foucault installed a giant pendulum from the 220-foot-high ceiling of the Pantheon in Paris. That's a lot of peace. An assembly of scientists and journalists watched as the floor turned beneath the giant pendulum. "The Earth turns," they shouted, mostly in French. Another strange thing about rotation is that although the Earth is rotating at a constant speed, the surface of the Earth is moving at all different speeds at all different latitudes. The same is true for every planet and star. At the equator, the surface of the Earth is moving the fastest at 1,037 miles per hour. That's much faster than the speed of sound, which is a mere 761 miles per hour. Halfway from the equator to the North or South Pole at 45 degrees latitude, the Earth is rotating at 733 miles per hour. Standing at the North or South Pole, it would take you 24 hours just to turn around one time, and that's both boring and cold. One result of these differential rotational speeds of Earth is that it creates belts and bands not only in the atmosphere, but also on the surface of the Earth. Jupiter, of course, is famous for the belts and bands in its clouds caused by the giant planet's rapid rotation of about 28,000 miles per hour. The belts and bands on Earth's surface are somewhat overlooked, but we've got them too. We have white ice at the North and South Poles, and between the two poles, there are alternating belts and bands of dry sandy desert and moist green vegetation. This essential geography can be seen most clearly when we view the Earth rotating in space. Space agencies use the differential rotation of the Earth to their advantage. They launch their rockets as close to the equator as possible. NASA uses Cape Canaveral near the southern tip of Florida. And the ESA, the European Space Agency, uses the Guiana Space Center in French Guiana, South America, almost exactly at the equator. Because the land under a rocket near the equator is rotating at a greater speed, it gives the rocket a boost into space that launch sites near the poles cannot provide. You always want to save fuel, you know. Speaking of Jupiter, as I did about 3 paragraphs ago, the axis of rotation of the big planet is even less inclined than that of the Sun. The Sun is tilted at an angle of around 6 degrees, while Jupiter is only tilted 3 degrees. Jupiter stands almost perfectly upright, which combined with the great speed at which Jupiter is rotating, its entire day is less than 10 hours, it turns Jupiter into a giant gyroscope. Jupiter's gyroscopic stability, combined with its massive gravity, gives stability to the whole solar system. Jupiter prevents chaos factors from disrupting the orbits of the other planets. In other words, without Jupiter rotating like a stable gyroscope, the solar system could never have stayed intact for the billions of years that it has. Exoplanet solar systems are showing signs of chaos in their orbits. They could use a gyroscope like Jupiter to hold them together. Rotation is the real hero here. As for the Sun, its differential rotation has a big effect on its sunspot activity. Sunspots are spots or patches that sometimes appear on the Sun's surface, usually at mid-latitudes in both the northern and southern hemispheres of the Sun. As sunspot activity increases on the Sun, sunspots begin to move closer to the equator. Few sunspots are ever seen near the poles. With differential rotation, the gases at the equator of the Sun are moving faster than the gases at the Sun's poles. This differential motion of the gases twists the magnetic field lines in the Sun, causing them to snap. Sunspots are magnetic eruptions rising through the surface of the Sun, hurling electrified gases far into space and emitting intense ultraviolet radiation, often in the direction of the Earth. Uh-oh. Well, have no fear, Earth's differential rotation protects us. Not only does our Earth rotate differentially on its surface, but also down into its center. Studies of seismic readings of shock waves from earthquakes indicate the metallic core of the Earth is rotating slightly faster than the surface of our planet. Scientists think that the differential rotation of Earth's magnetic core within the slower rotating metallic liquid creates the magnetosphere arising from Earth's poles and extending far out into space. This magnetosphere keeps Earth safe from electrified gases from the Sun. Hurrah for rotation! Far out! Now, the 9.0 megaquake in 2011 off the coast of Japan rearranged the mass of Earth's crust and caused the rotation of Earth to speed up. The day got shorter. Not much shorter, 1.6 millionths of a second, but we are accustomed to seeing the Earth's rotation slowing down. The Earth rotating through the tidal action of the Moon's gravitational effect on the oceans drains kinetic energy from the Earth's rotation, causing the planet to slow down. Each day is becoming longer, about 0.02 of a second longer. Well, I need to adjust my watch. Leap years, we all know, are when we add a day to the calendar every 4 years, on February 29th, to straighten up Earth's yearly rotation around the Sun, taking 365 1/4 days. But leap seconds are added to the clocks every so often to synchronize our clocks with the slowing rotation of the Earth, and allow the Earth to catch up with our clocks, as if the Earth is concerned about our timepieces. 27 leap seconds have been added since 1972. The last leap second was added on December 31, 2016, and made the clocks read 6:59:60 p.m. Yeah, I didn't notice either. But the sun's rotation has unexpectedly been speeding up recently. Usually it takes 86,400 seconds for the Earth to rotate, as measured by an array of atomic clocks in different locations on Earth and coordinated by a special service in Paris. Yes, they pay people for that. July 19, 2020 was the shortest day ever recorded, a whopping 1.46 milliseconds less than the usual 86,400. Gadzooks! If this keeps up for another 5 years, they may have to add a negative leap second to synchronize our clocks to Earth's increasing rotation. Computers and satellites won't like to see their clocks read January 1st at 0 o'clock, and they say time can't go backward. At least the Earth hasn't started rotating backward or stopped rotating altogether. That would be catastrophic. Everything would crash forward at whatever differential speed it was rotating on Earth. Yet that appears to be what happened to the planet closest to Earth, Venus. Venus rotates very slowly backward, in retrograde, and that is very unusual. How so, you ask? Well, there are several theories to why Venus rotates in retrograde motion, while all the other planets rotate in prograde or forward motion. Liquids inside a rotating sphere, like a planet, have a lot of inertia. That's why when you take an egg from the fridge, for example, and try to spin it, it won't spin. The liquid inside is just sitting there. Its inertia is resisting your attempt to spin it. However, if finally, after many turns, you manage to get the raw egg to rotate, it's hard to get it to stop spinning. If you do pick it up and put it back down, the egg will start rotating again, because the inertia of the liquid inside it is still going forward. You only stop the shell from spinning. Something like this may have happened to Venus. Wait a minute. Venus? Backspin? Tennis? I think there's a connection here, somewhere. We know that on Venus, the planet, one day is longer than 1 year. It takes longer for Venus to slowly rotate around backward one time than it takes Venus to orbit the Sun once. But Venus is slowing down dramatically, and by 6.5 minutes in the last 25 years. If there still is liquid inside Venus and the movement continues, we might see Venus completely stop spinning backward and start rotating forward again. Come on, Venus, let's get with the crowd. This business of retrograde and prograde rotation has got quite a bit of mystery to it. It seems that everything tends to rotate in prograde motion. If you shape your right hand like a ball and stick your thumb up to indicate north, then curl your wrist towards you, that's prograde motion. Your fingers on the left side of your hand are moving towards you. Black holes, solar systems, galaxies, atoms, stars, etc. all seem to rotate prograde, depending on which angle you view them from. Experiments at the Large Hadron Collider indicate that subatomic particles spin toward the left, prograde. It's starting to look as if we may be in a left-handed universe. Then why is it so hard to find a left-handed manual can opener or measuring tape? I don't know. It's a mystery.
Let's cut the Earth in half. You can see all of its layers. Here's the inner core. It's about 40 times hotter than the inside of your oven. That's the mantle, an ocean of hot lava. Here comes the crust of the Earth, the solid surface on which our civilization lives. But if you look up, there are many layers besides the atmosphere and the ozone layer. Scientists recently discovered a strange bubble here, which protects our planet from radiation. And nope, it's not the Earth's magnetic field. This bubble is made of radio waves. Our planet grows like a Christmas tree in the radio spectrum. But we're interested in low-frequency waves, the ones that let us keep in touch with submarines. So, radio waves are like light waves, or regular ocean waves. Look at this one. The distance between the two peaks is the wavelength, and the number of these waves over a period of time is the frequency. For example, there are 10 waves in this interval of 1 second. So, can you guess the frequency of this wave? Yep, it's 10 Hertz. Cell phones use waves with a frequency of 300 to 3000 megahertz. So, add 6 more zeros to that number. But waves of that frequency don't penetrate barriers well. Think of how you lose your cell phone connection when you're driving through a tunnel. That's because there is metal inside. It's a conductive material that weakens the radio waves a lot. Salt water is also a kind of conductor. So, if the submarine is deep enough, the thick layer of water weakens the signal. and we lose communication. To maintain it, we send fewer waves but make them longer. In the same amount of time, the frequency of the short waves will be much higher than the frequency of the long waves. That's why they're called very low frequency waves. But, as it turns out, these waves travel all over the Earth and even into space. This is where things get interesting. The waves collide with particles of radiation from the sun. We think of the sun as a friendly giant giving us light and heat, but it actually emits a lot of harmful radiation. Each flare, or the electrical discharge of material on our home star, causes an even greater burst of radiation. These particles fly to our planet, just as radio waves do. They travel 93 million miles from the sun to Earth in 8 minutes and crash into our bubble, which acts as a shield. Basically, radiation particles from the sun accumulate in the radiation belts around the Earth. Our planet's magnetic field traps them, and a recently discovered bubble of very low-frequency waves lies right below this radiation belt. It helps us repel some of the harmful emissions. Analysis of old studies confirmed that the radiation belts used to be much lower and closer to Earth. But when our civilization began to use radio actively, our waves raised that belt higher. No one expected such an effect from simple radio waves, but it'll give us a way to protect astronauts in the future. When you're on Earth, its magnetic field keeps you safe from radiation. You can physically see it when charged solar wind particles make the air particles at the poles of our planet glow. This is an aurora. Next time you admire this beauty, know that it's actually the Earth saving you from some extremely harmful rays. But if you're outside the Earth's magnetic field, somewhere in space, I have bad news for you. Nothing protects you there. This is a big problem for astronauts who spend months on the International Space Station. Perhaps scientists will learn to create protective bubbles of very low frequency waves around space stations and spacecraft. The same is true for other planets. We're probably going to colonize Mars. There is no magnetic field there, and nothing can protect you from radiation. But if you create an artificial bubble there, you can reduce the harmful radiation. Another invisible bubble protecting us is the atmosphere. It's like a layer cake or an onion. Each level of the atmosphere has its own properties. The lowest layer that we live in is the troposphere. This layer contains 80% of the weight of all the air on the planet. It's also the main place where water vapor lives. And this is where the machine called weather works. The sun sends rays of energy to the Earth. Our planet's surface reflects them and heats the air in the troposphere. This makes it move and change places with the cold air, so all the wind, cyclones, storms, and tornadoes only happen in the troposphere, up to about 7.5 miles high. That's why commercial planes fly at an altitude of around 6 miles. The wind or other bad weather conditions hardly affect this area, and the air here is not as dense as it is down on Earth. Flying 1 mile above sea level is like moving through a biscuit. It's hard, but at a 6-mile altitude, flying feels like moving through light whipped cream. The plane almost feels no resistance, so it's a win-win. They save fuel and keep the passengers safe. A couple of significant downsides are that it's very cold and you can't breathe there. It's cold because there are very few air molecules to absorb heat from the ground and transfer it to each other. You wouldn't be able to breathe here for the same reason. That's why planes are equipped with oxygen masks, just in case. Let's go a little here. This is the stratosphere. There's even fewer air molecules up here, and that's where the weather probes fly. They're the kind of small balloons with computers people use to predict the weather. This part of the atmosphere also contains the well-known ozone layer. This is our shield against harmful ultraviolet radiation. Ozone is almost the same as oxygen, except it has 3 atoms in it. When harmful ultraviolet rays enter our atmosphere, they crash into the O3 molecule. The ray breaks the molecule into O2 and another oxygen atom. The ray itself is converted into heat, but the ozone regenerates quickly. A single oxygen atom joins the O2, and the ozone molecule is ready to protect us again. It's the invisible shield that protects us from radiation. It gave birth to all life on Earth. As our civilization developed, we started to emit freon gas into the atmosphere. We used to fill our old refrigerators with it. A single chlorine atom would detach from a freon molecule when in the air, and then it would bind a single oxygen atom. Now, the ozone can't regenerate like it used to. Fortunately, we banned the use of such harmful gases, and the ozone layer began to regenerate. Scientists expect it to fully recover in the middle of the 21st century. The stratosphere ends at about 31 miles. The next layer is the mesosphere, the coldest of them all. On average, it's about negative 140 degrees Fahrenheit. That's 5 times colder than your freezer. This is the layer of the atmosphere where incoming meteors start to ignite because of friction in the air. Then they will eventually burn up completely. The air here is too thin for airplanes or balloons to fly, but it's still too dense for satellites. So, this layer of the atmosphere is not well studied. The next layer extends from 55 miles above sea level to about 500. That's a little more than the distance between Las Vegas and San Francisco. Kármán line is situated in this layer of the atmosphere. This is the boundary between our planet and space. The thermosphere is where all our spacecraft and satellites fly. It's also home to the International Space Station. The temperature rises extremely. The air here is about 10 times hotter than your oven can produce. It's all due to solar activity. But you would never be able to feel this heat. The air molecules that carry the heat here are so small that you would literally float between them. Imagine a giant pool with only 3 drops of water. That's the thermosphere. And the highest layer of our atmosphere is the exosphere. This is the widest layer of our air bubble. Scientists believe its boundaries are about halfway to the moon at 120,000 miles. This is the point where the pressure of solar radiation begins to exceed the Earth's gravity. It's still part of our atmosphere. This means that astronauts who went on various space missions and have been on the ISS have actually never left the Earth's atmosphere.
84 million years ago. Many modern mammals, birds, insect groups, even the first flowering plants are already there. Dinosaurs are still roaming around. They have around 20 million years left before the asteroid. T-Rex, a fearless hunter, becomes the king of the dinosaurs. And the Earth tilted by 12 degrees. Picture our planet as a chocolate truffle. The shell is hardened, the center is viscous, with semi-solid matter. Its top layer, the crust, consists of tectonic plates that are like puzzles. Continents and oceans come on top of these plates. 84 million years ago, the mantle and the crust started rotating around our planet's outer core, then going back. If you'd been able to see it from space, it would have seemed like the entire planet has tipped over on one side. Today, it would have moved New York City to where Florida is. Let's say our planet is like a spinning top. It whirls perfectly if the weight on the top is evenly distributed. But if you move some of the weight to one side, it makes it tilt. It may have been caused by the moving of the tectonic plates and one of them sinking under another. We might be drinking water older than our solar system. Some scientists think the water we have on Earth may have come from ice specks that were floating in some sort of a space cloud more than 4.5 billion years ago. Lakes aren't always peaceful and relaxing. They can also explode. It happens when there are volcanic gases under the surface that can burst, rise to the surface, and cause big damage. The Earth's rotation is slowly going through time. Every year, the moon gets a little bit of energy from our planet and slowly drifts farther away from it. These two things are making our day longer, but really slowly, around 1.4 milliseconds every 100 years. That means when dinosaurs were around, the day was 23 hours long. Our planet used to be purple. One theory says ancient microbes didn't rely on chlorophyll to absorb the sun, but on different molecules. They absorbed green light and then reflected back a nice purple color. Every time you take a dip in the ocean, remember you're swimming above more than $700 trillion worth of gold. Not on the ocean floor waiting for someone to get it out, but in tiny particles dispersed in the water. The deepest place on our planet is the Mariana Trench, a spot in the Pacific Ocean, 36,201 feet under sea level. But the deepest place that's not covered in the ocean is in Antarctica. Technically, it's hidden below thick and deep layers of ice, goes more than 8,300 feet below sea level. There are 60 tons of dust falling from space to our planet every day. You probably inhale a pretty good amount of this cosmic dust while just going to work. It's dust, small particles from comets, meteorites, and some other space bodies. Dalal, Ethiopia, is the hottest inhabited place on our planet. Between 1960 and 1966, the temperature was 106 degrees Fahrenheit, and even in the wintertime, the temperature goes up to 98 degrees Fahrenheit on average. 8 minutes and 20 seconds. That's the time sunlight needs to travel from the sun to our planet. It's still not that much compared to what it takes for the light to reach Pluto. 5.5 hours. Almost 70% of the fresh water we have in this world is held in ice sheets and glaciers. More than 96% of the total amount of water on Earth is in the oceans. The Earth is like some sort of big magnet. Its inner core is actually a sphere made of solid iron, with liquid iron surrounding it. All those variations and changes in density and temperature create some sort of force, which makes the iron produce electrical currents. They are lined up by the planet's spin, and together, they create a magnetic field. There are many stars in the Milky Way, 100 billion, but way more trees on our planet alone, around 3 trillion. You can tell how old the tree you're looking at is by its rings. They can also tell you more about the conditions of a given year, too. When these rings are thin, there was a drought, while the thick ones say it was a rainy period. Earth is a magical planet where even rocks can walk, at least some of them, in Death Valley, California. They leave trails so you can record the path they've passed. Some of those biggest rocks have left tracks behind up to 1,500 feet long. Smooth-bottomed rocks wander around, while those with rough surfaces tend to leave straight tracks. The world that surrounds us consists of atoms, and they seem to be solid. But 99.99% of them are just empty space. An atom is just a really small nucleus and a cloud of electrons surrounding it. These electrons are particles, but they act like waves. They don't exist in one point but are spread over a range of probabilities and occupy lots of space. Take the empty space in our atoms, and all the humans could fit in a really tight space like the volume of a sugar cube. Australia is slowly shifting north, 2.75 inches per year because of tectonic movements. Australia is one of the top continental tectonic plates that move faster than others. You'd need 400,000 moons to reach the level of brightness the sun has. Sounds a lot at first, but the moon only reflects the light coming from the sun. It doesn't make its own. And even though that's not enough, its brightness depends on the exact angle between the sun, moon, and the Earth. The planet we live on used to have 2 moons, or at least some scientists believe so. They figure the side of the moon that faces the Earth is relatively flat and low, while the other side is way thicker and crustier. The theory says that there used to be the second moon that collided with the thicker side. Some believe there's still a second moon. It could be not a giant space body we see clearly in the sky, but some sort of a small asteroid pulled into the Earth's orbit. Air doesn't mostly consist of oxygen. Almost 78% of it is nitrogen. If you want to see some pretty steep rocks, go to Canada, Auyuituk National Park. It has the biggest vertical drop in Canada, the tallest and the steepest cliff, with 105 degrees of overhang and 4,000 feet of rock. A team of 4 American men finally made it to the top in 1985, although there were 30 attempts for that before. It took them 33 days to get up. The Pacific, Atlantic, Indian, and Arctic are the 4 world's oceans. The 5th is confirmed to be the Southern Ocean. It's not defined by the continents around it, but by its Antarctic current that goes from west to east. Research shows this current was created more than 30 million years ago when South America and Antarctica had separated. This allowed water to flow around the bottom of the ocean without any barriers. Melting glaciers and ice sheets means more water in the oceans. It adds the extra weight of all that liquid pressing down the sea bottom, making it sink. The Earth's surface looks solid and kinda permanent, but every 500 million years, it goes through a process of regeneration. Tectonic plates crash into each other. Continental crust creates pressure on the oceanic crust, and that pressure activates the volcanoes. Through time, all this results in regenerating and replacing a majority of the Earth's surface, just like our body regenerates skin cells, replacing old with new ones. Out of all planets in the solar system, Earth is the only one with the outer crust that's broken up into huge surfaces we call tectonic plates. This is an important process that allows the formation of oceanic trenches and mountains, and also helps with protecting the Earth. When microscopic planets that live in the ocean are gone, they fall down to the bottom. The remnants go back into the interior of our planet and get recycled, and eventually end up in the atmosphere, protecting us from overheating and turning into Venus, the hottest planet in our solar system.
It's there. I finally see it, for the first time in my life. Grayish body far away in the sky, hidden behind the clouds, the size of 1/4 of a full moon. It won't be there for long. The last time it was there was 33 years ago. And we'll have to wait for 33 years more to see it again. Tellus, the mysterious planet humankind still have so much to learn about. For a long time, Earth was the only planet quietly traveling its circular orbit around the center of our solar system, the Sun. Our solar system was generally a pretty stable place. Jupiter, Saturn, Mars, and other planets, they all acted in a predictable way. Always the same orbits. Until some time ago, something unexpected happened. Another planet entered the Earth's orbit. No one knows where exactly it came from, since it wasn't one of the 7 planets from our solar system. We had advanced devices that tracked asteroids, meteorites, and other space bodies. But scientists were still terrified when they saw such a big, round body suddenly coming toward us at a great speed. First, they thought it was a huge asteroid and were afraid it would collide with us. Humankind was prepared for the worst because it was too late to deflect it. But when the huge body came closer, to the distance of 93 million miles, which is the average distance between the Earth and the Sun, it suddenly changed direction. We now know that's the closest it could get to the Earth, with the size similar to our planet. The orbiting body needs to meet 3 criteria to be called a planet. It needs to be a perfect sphere, orbit the Sun, and can't orbit any other body, like another planet. It also needs to have a clear orbit of any protoplanets, planetesimals, or other planetary competitors. Scientists were tracking the orbit of the new planet they later named Tellus, which is a Latin word for Earth. When it entered the Earth's orbit, it was like something happened with their gravitational forces, so these 2 planets created a completely new orbit, in the shape of a horseshoe. Planets could be in the same zone around the Sun in such an orbit. That means they don't move in a circle around a star, but each goes along the edge of some sort of track in the shape of a horseshoe with crescents that face each other, like 2 halves of a broken ring. For example, Saturn and its 2 moons, Janus and Epimetheus, they dance around Saturn with the stable horseshoe orbit and travel around 93,000 miles from Saturn, beyond its main rings. The closest they come to each other is 9,300 miles. Nothing occupied our media for years but new mysterious events. It was chaos at first because we didn't know how things would end. No one went to school, work, college. We were all waiting for directions on what to do. People were first very afraid, but later excited when we found out that's a planet similar to Earth, which means we could get new friends. Scientists believe Tellus used to share the orbit with some other unknown planet in another solar system. We never had 2 planets sharing the same orbit, but some other solar systems could have it. When 2 planets share the orbit and get closer, one can kick another from the orbit in the unknown direction or even be pushed into the Sun because the gravitational forces of 2 planets interact. If 2 gravitations would attract each other, they could start moving towards each other and bam, big collision. Or they could successfully share their orbit, shaping a horseshoe orbit-like path, something that happened with Earth and Tellus. It's not the first time it happened to Earth. 4.5 billion years ago, when the solar system existed for only a few tens of millions of years, there was a space object as big as Mars moving towards our planet and slammed into it. The theory says the Earth pulled the debris from that planet into its orbit, and those pieces eventually formed the moon we have today. The collision probably caused resurfacing on the Earth. The oldest rocks we found on our planet are still younger than some meteorites we found. Uranus probably also had a huge collision. Billions of years ago, there was a space object at least twice bigger than the Earth, and it came very close to Uranus, the gas giant. 2 bodies collided with the force so powerful it made Uranus shift into its side, but it survived. But it's been rotating on its side, different than any other planet in our solar system ever since then. The early solar system was created because gravity pulled a cloud of gas and dust together. It was a chaotic place where debris was constantly slamming into other planets that were growing and forming at that time. Two planets can hardly share the same exact orbit because they can't remain stable. Quasi-stable orbit maybe, which technically means no order. Everything is unstable. Why we can't be completely relaxed with Tellus, even though things look good now. It doesn't mean the collision will happen right away. It can take billions of years before that. There are things called Lagrange points, 5 specific points where the gravitation of some planet and the Sun cancel out. If you consider masses as just one planet and the Sun, all 3 bodies can move in a predictable orbit forever. But out of these 5 points, only 2 are stable. Anything that happens in the other 3 will cause trouble. Also, 2 of them, L4 and L5, are points where asteroids collect. Gas giants have thousands of these, but our planet has only one, the asteroid 3753 Cruinia, and it's in the quasi-stable orbit with our world. It's not going to remain stable forever, but if it was like this, 2 planets can share orbits. Days are a little bit longer now, the year is also longer. We still can't settle for the calendar because the conditions are still changing and the planets are still adjusting to their new orbit. The climate is the same for now, probably similar to one on Tellus, since we're in the same disk around the Sun. We discovered it's pretty similar to Earth and has similar conditions, which means we could maybe live there in the future. The planet comes to the closest point every 33 years, and later it's behind the Sun, so we're slowly collecting data about conditions. We were thinking about moving there, but then something exciting happened. We started getting messages from space for the first time. They came by radio frequencies in some unknown language. We're currently trying to decipher their messages and, at the same time, preparing for their first visit. We believe whoever's out there comes in peace. They've come a long way to our solar system. Today is the day we are going to visit Tellus for the first time. In fact, the spaceships are going to be there any minute. They went there 9 days ago. Journalists are ready. People are cheering. Cameras are on. We're all waiting. Today, Tellus is at the closest point and won't stay there for too long, maybe a couple of days. So we don't have that much time to explore it and see who's there. I hope we'll be able to visit them, make new friends, collaborate, travel to see new places. Till now, we only saw some pictures scientists took from the distance. It seems they have lots of water. Researchers believe many waterfalls, lakes, but much deeper and wider than ours. Perhaps hiding some magnificent creature we don't have. They think there could be volcanoes. Maybe we'll find something bigger than Olympus Mons on Mars, which is the biggest volcano we found in our solar system, which is the size of Arizona, a staggering 370 miles across. Maybe it has super strong winds, like Venus, whose winds are 50 times faster than its rotation. Who knows if there's water ice, the matter that exists all over our solar system, some in shadowed craters on the Moon and Mercury. Maybe Tellus will change its size, like Mercury, that has cliff-like landforms with relatively small fault scarps, so we believe it's slowly but constantly shrinking. Tellus perhaps has tall mountains, like Pluto, which isn't the planet but still has impressive icy mountains, 11,000 feet tall. Anyway, today's the